the road mapping. With the road mapping activity, we'll fill that in, I guess. Moving through the technical working groups, working with all of our government partners, making sure that we're addressing the important areas. We have now published our request for proposals that we call the Project Call Guidebook. Next, we move into the pre-submission consultation phase. This is something that is very different between most government proposals and Nextlex proposals and the process that we use. We highly encourage you, we very strongly encourage you to talk with us during the process of developing your proposals. We will provide you feedback. We can help with interpreting. If you're asking yourself, does this really align to what the Institute is looking for? Ask us that. We'll tell you. We will tell you exactly what we mean by a particular word or phrase. If you're looking for a partner, you say, like, I've got 80%, on my existing team, but there's still this 20% of the work that I don't know who is really somebody that I can work with on that. We will point you to anybody that we know who has that kind of capability and interest. We're not going to pick one and send you there. We'll identify every one of them that we know, and then we'll make the introductions for you so that you can decide who would be the best partners for you. That's a part of the pre-submission consultation process. You then go off and develop your proposals, submit the proposals before the deadline, and then we go into a peer review process where our members and our government partners are the reviewers, and we do quite a lot of work to try to make sure that there's no conflict of interest. If, for example, if anybody in a large company has submitted a proposal to topic 10.1, no one from that company can review proposals in topic 10.1. That would be a direct conflict of interest, so we don't allow it. We also ask for anyone to self-identify anything they perceive as a conflict of interest, or that might be perceived by others. So we are very diligent about eliminating that. Go through the review process. We work to make recommendations based on all of those reviews that we have, bring them to our technical council for a vote, and then to our governing council for a vote that narrows the selection and finally approves the final set of projects that we're funding. Question? Thank you. Yes, that's right. And so because our governing council and technical council are made up of members as well, we also go through a process of recusing the members of the technical and governing councils from voting in the topics for which their companies have submitted proposals, whether they are up for selection and consideration at that point or not. Keep doing this. All right. Dates, important dates for Project Call 10. We are sitting here at the Proposers Day, which is the second line in this table, toward the end of September. The first date for pre-submission consultations is next week, so we highly encourage you to do this early in the process. That's when they can have the greatest impact. If you want to schedule it the day before the proposals are due, not a lot of time for you to make changes. It has happened, but there's not a lot of time for you to make any changes based on the feedback that you get. We require cover sheets, what we refer to as cover sheets, which is really just the submission information. What's the topic you're submitting on? Who is your team? What's the budget that you're requesting? That information is requested 1 week. The deadline, I should say, is 1 week before the submission deadline. What that allows us to do is begin to line up the reviewers so that we can do all of that elimination of conflict of interest. That way, once we receive the proposals on May 21st, we'll be able to turn them around much faster. We've saved ourselves a week worth of work in aligning the final reviewer slates and put those out for review to then get ourselves to the end goal of funded projects fastest. The anticipated date for the Tech Council review is in late July, and the Governing Council review a couple of weeks later in early August. So that lets you know that we are aiming to have award announcements made by mid-August, early to mid-August, and then certainly the timing of project starts is dependent on negotiation of the development agreements, but September is reasonable, is very reasonable if the selected organizations are willing to work quickly through the contracting process. All right, major themes. The objective, of this project call, every one of our project calls has a somewhat different character. This one really focuses on manufacturing challenges to demonstrate key capabilities in hybrid electronics. We continue to emphasize the importance of technology transitions into both defense and commercial applications. And this is especially true in PC-10, where if you did a comparison of prior project call guidebooks to this one, you will see that we have included a special emphasis on technology transitions and the importance of those. We are really looking to demonstrate, we are 10 years into this manufacturing institute, and rightfully so, we are asking the questions, some of our sponsors are asking the questions, what is the impact that the institute has had? Those transitionable technologies is the ultimate impact that we're seeking to have. And so we're not funding products, but these should be technologies that are needed by the marketplace, whether they are a manufacturing process or a manufacturing tool or a product like demonstrator, they should address a real need. And so that's where we're working to take these projects. We also want to increase the engagement across the industrial base and broaden participation in the project calls. And so one of the topics, as we've had in the last several calls, addresses that specifically. But we will work with any of you in that pre-submission consultation process to help any proposer propose against any topic for which they're eligible. Key themes: addressing high priority cross-cutting technical gaps. So this is how we've prioritized the gaps within the different roadmaps. Higher readiness level projects. So as this field has really begun to have products hit the market, the need for reliability and standards and demonstrating capabilities in relevant environments is of increasing importance. We have a topic that seeks specifically to leverage artificial intelligence and machine learning in hybrid electronics manufacturing. So that is an important theme. It's an important theme in just about every sector of industry now. And so looking to work through all of the membership through these projects to have an impact in that space and to be impacted by that space. And then demonstrating capabilities and transitionable solutions for DoD relevant needs, including electronics repair and lowering life cycle costs. This is an evolution of of work that's been done in both project calls and some agency projects in the past several years. All right. Some important considerations. Okay, some of those of you who have been part of the NextFlex community for a long time know that we used to do a two-stage submission process. We eliminated that several years ago. These are one-stage proposals, full proposal submitted in the first round. There is no pre-proposal. We replaced that with the pre-submission consultation so that you can get feedback on your idea and really tailor it to address the needs and objectives of the call and get some feedback there. There's a clear focus on projects that have near-term commercial impact. I've already talked about technology transitions probably 3 or 4 times by now, and so that should tell you the importance that has to us. To be competitive, that means that we really need projects to identify what is the market need, describe who that customer is or will be, including the requirements that are driving the solution. So if you're developing a demonstrator in one of the demonstrator topics, not just show us that you can develop that demonstrator, but tell us why it needs a hybrid electronic solution. Why is a conventional printed circuit board solution, for example, not going to work in that application? Because ultimately you'll be competing, if this moves from demonstrator, after the funding, you continue developing it toward product, you'll be competing with anybody else who's developing those solutions. And it will drive toward the lowest cost that meets the requirements and the most reliable and the best known and the best understood. And so those are very real challenges that any new technology faces. And so making sure that we understand why this solution is the right solution, why this is the one that's required, that makes a very strong proposal relative to one that says, but look, I can do it with this really cool technology. We love the technology as much as you do. We want to make sure that it's going to go somewhere. All right. Proposals that include an engaged DoD stakeholder will be given strong preference. So what we mean by that is proposals that are addressing a DoD need and for which the kind of solution that you're proposing to develop aligns to that stakeholder's needs. If you have a program office that says, yeah, I have this problem. If I had your solution available to me, it would be on my program of record. It would be on the platform that I am working to develop. That would be the absolute strongest kind of support that you could bring, that letter. But there are plenty of other things below that. Expressions of interest. If you've got somebody in a DoD lab that's developing a technology that this is going to augment, that would be another type. There are lots of ways that you could go about demonstrating that alignment and that stakeholder interest. Happy to talk with any of you during pre-submission consultations about those. If you have a question like, does this meet what you're asking? It's hard for us to anticipate anything you might come with, but if you talk to us about it, we can give you direct feedback. And then just the final note for any organizations that are not NextFlex members, you are welcome to submit proposals. We love seeing proposals from non-members. if a proposal is selected for award prior to actually signing a contract, every organization that is either a lead or receiving funding as a development partner on the project has to join as a NextFlex member. That covers all of the intellectual property requirements and all of the policy that we have behind that. It also covers the information sharing, beyond the IP policy side of things, as well as just laying the rules of the road so that we're all playing by the same rules. All right, items to consider. Total NextFlex funds for this project call are $5 million with an estimated total project value, including cost share, of greater than 10 million. Historically, we have had proposals come in at well above the 1-to-1 cost share requirement. 1-to-1 is the minimum. We do get proposals that are well above that, and the historical average is quite a bit higher. The funding per topic ranges between $400,000 and $1 million, and you'll see that in a moment about what each of those amounts is. Projects are meant to be of relatively short duration, modest duration, we typically say 12 to 18 months. The quicker you can do the project, if you can do a project if you're going to propose a project in 18 months, but you could do it in 12, consider proposing it in 12. You'll have that same impact in a shorter time. If you need the extra time because, you know what, I'm going to do 9 months of reliability testing after I've done 9 months of development, okay, that's an 18-month project, absolutely. But there's from our perspective, there's no reason to push the project duration longer just because it's allowable. We anticipate funding 1 or more projects in each topic area. That's not guaranteed. We have had examples in the past where, because of the strength of the proposals that are received in the various topics, we choose to fund 2 in one topic and none in another. There is no pre-allocated funding per topic area, with the exception of some agency funding that we have in this topic to fund the life cycle cost improvements in the 2 topic areas. And so that money would then be distributed between those 2 topics. When it's appropriate and when it's possible, we would like projects to build on prior developments, either through your companies or through prior project calls. That pushes us farther down the development path, which is, of course, the objective. All right. From a funding perspective and membership, we think we've already said much of this. Project funding or cost share of at least 1-to-1 is required by the recipients. We do not dictate how the project team breaks down that cost share. If one of the project team members wants to contribute all of the cost share that's required on the project, perfectly allowable. If you want to distribute it evenly across the members, if you want to distribute it proportionally among the members of the team, that is up to you. It's not something in which we take a stake. If you have a third party that wants to come in and contribute that cost share, whether that's a state or a non-development partner company that just says, I'm really interested in this and I'll pay the cost share, that would be fine as well. These are all things that you get to decide as a proposal team. Cost share can include the labor, the materials, use of equipment, travel. You're gonna be presenting at a NextFlex event because we invite you to do that. That's all allowable cost, and can be part of the cost share. Any recipient of NextFlex funding, I've already said this, has to be a tier 1 to 3 NextFlex member. The observer tier is not eligible for receiving funding, but can upgrade to a tier 1, 2, or 3 membership. It applies to the lead developer as well as all of the development partners. So if a company is a supplier of a COTS part or just a commercial service, like have some parts machined at a machine shop for building a tool, those companies do not have to join. But if they're doing development work, they are required to join as NextFlex members. It covers, as I said, all of the IP and all the other rules of the road. And then finally, federal government partners. We really encourage you to bring federal government partners into your projects. If you want to work with AFRL or ARL or ONR or some other service lab or national, DOE national lab that's going to be contributing to the project development, that is absolutely allowable. However, we cannot send funding back to the federal government to pay for their work. So they would have to be self-funded through some other mechanism. Highly encourage collaboration with them. Getting toward the end of my time before I hand off to Nick. Our objectives. Reliability and standards really cuts across all the topics. In the guidebook, you see that there's a description of the objectives relating to reliability and standards. They're not the topic. They're not a standalone topic, but we encourage those to be included in any proposal that's submitted because the field is at that stage of development. If a project is focused on process development, we really want you to document those processes and communicate that in your reports and in your webinar presentations at a level that others could replicate that. The projects really need to include the following, the kinds of deliverables that are shown on there: data both raw and processed, on the materials and processes, all of those elements. Flowchart your process steps so that everyone learns from these developments, including design information. So if CAD drawings are important, that would be something to share. Details on the methods of test and measurement performed, which helps to establish what is the technology readiness level and the manufacturing readiness level. Really identifying what are the specific tasks and outcomes that led to those TRL and MRL advancements. That's important. That helps others to get better in the future as well. And in addition, it validates your actual TRL and MRL. And finally, we are looking to understand the cost of devices that are coming out of these. Both all of us, I think, are trying to understand that. And so understanding the cost model framework. Now, we say framework. We understand that when you're actually building out your internal cost model to understand what something would really cost you when you do the manufacturing, there's a lot of sensitive company information in that. So your actual labor rates or overheads or all of those elements of that cost model, we don't need to see all of those. We want to see what the final outcome is, your assessment. We don't need to see those details, but the framework for how you went about it, like, did you include the energy cost, in your cost assessment, for example, would be one way to consider it. Have you really built in all of those costs? Really important in understanding whether those assessments are complete. I keep doing that. All right. Relevant process information. I'm not going to read these off to you, but when you're building out a process, understanding really how that process works, all of the information that someone needs to be able to replicate that, to learn and improve the way that manufacturing in this field is done, is of interest. Finally, this has long been true, but I think we added this bullet this year just to emphasize it at this part of this stage in the project call. We do request physical hardware deliverables for every project. Projects take all different forms. If a project is developing a manufacturing process, then those physical hardware deliverables are not going to be something that looks like a finished product. They may be test coupons, but it demonstrates the work that's done. It allows us to showcase those, in our displays here. It allows us to provide them to our sponsors and our partners at the DoD so they can see the work that's been done and really see that tangible outcome. So we're very happy to talk with you about what form that might take. It's a pretty hard requirement, it's a pretty strict requirement to have this. However, if there's a project that for some reason you think really doesn't make sense, pre-submission consultation, just like so many other things, we can talk about it there. Maybe you're right, but maybe we're also going to suggest like, oh, well, how about this? Might this be something that you could provide? And I think chances are we'll figure out that there is something that would work. We bring that up now because if we don't bring it up now and get you thinking about it at this stage, it gets pushed out to the contracting stage or the pre-submission consultation. But if it still survives as an outstanding question for you, then we're going to end up negotiating that with you as part of the statement of work for the project, and that just slows things down. Finally, a note on platform demonstrator deliverables. So the platform demonstrator topics really are seeking to demonstrate product-like capabilities. We're not funding product development. So let's talk for a moment about the difference between a platform demonstrator and a product. A product is a competitive offering that you're going to put on the market that really needs to address every need in a way that competes against every other product that might serve the same needs. A platform demonstrator doesn't have to have all of those things that are going to make your product competitive relative to other products, but it should still demonstrate the product-like functionality that has it addressing the important characteristics of this system, whether that, and that should include things like the packaging, the software and firmware support that make it look, at least at some level, like a functional end-use device. Now, I put that in quotes. Pardon? It's interesting. So many thoughts. So the idea here with these demonstrators is to have capabilities that can be transitionable more quickly. And I was beginning to say that I put the idea that they be complete in quotes because they may be components, they may be subsystems, they may be complete systems that have every requirement and they're a standalone product on their own, or would become standalone product on their own, but certainly platform demonstrators can be subsystem or component as well. I want to emphasize that point. So finally, strongly encourage you to talk with us about these. And then if you are selected for one of these projects and you're going out and you're going to demonstrate these platform demonstrators in a relevant environment or in an operational environment, which should be TRL 6 or 7, we really would like to work with you to create, video and images and things like that of those types of relevant or operational, field test demonstrations. The value of that, to be able to show that this thing really does what it's meant to do, is extremely high. And we'd work with you also to figure out, like, should this be an event to which partners get invited, whether that be partners on the project, the institute, government sponsors, whomever. All depends on the type of demonstrations being done. This is a conversation to have. It's not a requirement. All right, at this point, I'm going to hand off to Nick, who will walk us through the details of the PC10 topics.
All right, thank you, Scott. Good morning, everyone. If you don't know me, I'm Nick Morris, Deputy Director of Technology at NextFlex. I'm going to walk you through the 6 topics in PC10. Scott laid the groundwork for where they came from through the technical working groups. So first, thank you to all of you in the room, all of you attending virtually that participated in those road mapping meetings throughout the last several months, back from we started in late August, early September. That's imperative. This is really supposed to be a member-driven effort. We really want the input from the members, and this is the direct output of that. So we want to understand the needs, and that's exactly where these topics came from. So thank you. Thank you to everyone. So 6 topics, as I mentioned. This is a grid. I'm not expecting you to be able to read this or interpret this, but this is basically our accounting and our metric tracking within the guidebook. This is posted, but it lays out the 6 topics, their titles, the maximum duration for the period of performance. Most of them are, which is a 12-month effort, which I'll talk about when I get to that. Maximum funding allowed, Scott mentioned. Most of the projects are $500,000 in maximum institute funding available. So with a at least a one-to-one cost share, each project over $1 million in total value. We do have 2 topics, 10.3 and 10.5, which are platform demonstrator topics focused on developing those platform demonstrators that Scott just described. It's been a couple of project calls since we've had these larger efforts that are meant to develop these platform demonstrators. That was feedback that we've heard from some of the members, some of the government partners as well, is in the interest to showcase new capabilities. It was back to PC7 since we really had a topic dedicated to that. So we really wanted to put funding into advance and be able to show those new capabilities that have been developed and are being developed now. So in PC7, when we had that demonstrator topic, we had 24-month period of performance. We deliberately kept it to 18 months because we want to be able to go faster. We want you to show you might have a larger team, might be moving a little more quickly, but we really want to be able to deliver on those demonstrators and show near-term viability of those technologies and near-term impact. The last topic, 10.6, that is our open topic for new project leads. We've had that as a topic since back to PC6 now. That's only available for those that have not led a project call before. I'll talk more about that, but that's a $400,000 maximum 12-month period of performance. So that really is an opportunity for somebody, maybe you're a NextFlex member that's been around, you've never led a project, but you'd like to start leading projects, or a non-NextFlex member that really wants to join and get engaged, but maybe doesn't understand the lay of the land and doesn't have experience leading a NextFlex project because they are somewhat unique. That's a great opportunity that we've seen be very successful for new team leads to come in, maybe run a slightly smaller team, understand all that goes into it, and then leverage that into a follow-on project, maybe in a following project call, because now you understand the mechanisms, now you understand what the lay of the land is. So that's we've had great success with that to really engage more of the industrial base. We also have a series of X's and O's tic-tac-toe board up there. Don't worry about that now, but I would encourage you to look at that. That's, again, our metrics tracking to try to understand, these are broad topics, but which technical working group those technology gaps came out of, where we think the impact will be, either directly or indirectly, so we can make sure we're really taking a balanced approach to this And we've continued each project call cycle, we're increasing how we're tracking metrics in terms of impact, where the technology, what gaps we're addressing that were identified through the road mapping process. So it's great to show in your proposal alignment with the technical working group gaps, whether you're a member and you can look at the full member benefit version of the roadmaps or look at the public summaries, those have gap areas that are of key interest. So it's a really important evaluation criteria to look at alignment with what we call out as the gaps on the roadmaps. Similar to the last several project calls, the topics are broadly defined. We're following the same structure. It's evolved slightly. But we really aim to open the aperture in terms of solutions. We don't want to be too prescriptive in terms of, we want this exact solution. We're making it broad deliberately, and then providing what the requirements are in a short, paragraph or two that describe for this topic to be up to align and to be responsive to this topic, you need to do these certain things. But then here are some examples of areas that are of particular interest, but are not requirements. So that's what you'll see. Each of the topics, except for topic 10.6, follows the structure of laying out what the requirements are, and then including examples that are of particular interest, but are not requirements. So projects that if you propose all that, every requirement or every description of what that example lays out and you're responsive to that, that's great. You can do aspects of it. You don't have to follow those examples at all, but if you have a proposal that aligns with those requirements described in the first couple paragraphs, fantastic. Maybe it's something we didn't think of. We weren't thinking of the right solution. We really want to be able to take those proposals in, look how they align with our roadmaps, get the feedback from the reviewers and say, oh, fantastic. We weren't thinking about that, but this is a great solution. We want that option. So again, this is a great thing to bring up during the pre-submission consultations as well. Alignment to the topic. We can provide guidance on that as these ideas develop. We constantly get questions. Oh, it kind of aligns with this topic. It kind of aligns with this topic. Happy to provide our guidance and experience during those calls. So I'm going to walk through the topics. I'm going to provide a very high level overview. Again, the guidebook is the reference, but I just want to touch on sort of the impetus, how these came about, and what we're really looking for in these topics. So the first one, excuse me, topic 10.1, this is maturing and de-risking hybrid electronics manufacturing processes and devices. So this is a $500,000 maximum 18-month effort. This is really looking at one of the major themes that Scott highlighted, what we discussed throughout the technical working group meetings last fall, is really continuing to push maturity of these enabling manufacturing technologies. We've been an institute for 10 years. We've explored a lot of different manufacturing technologies. A lot of them are showing real promise. A lot of them are being adopted. So we really want to continue to push that maturity for both the manufacturing processes and the components that are a result of those manufacturing processes. And that's a big range. We include language in there that describes we're really looking at additive multi-layer processing for PCB manufacturing, structurally integrated electronics, advanced semiconductor packaging. And that's quite a wide spectrum of dimensional range, looking for different, critical resolutions, and that's quite a scale. That was deliberate. Depending on what your manufacturing process is, depending on what's driving your requirements in your application, you could be looking to do a line space of, single-digit micron for a packaging application. It could be, hundreds of 100 microns, 50 micron lines. But you have a very unique process to get very high yield on these multi-layer, multi-material print structures. But for your application, you're doing structurally integrated electronics. That's what you need. That's what's driving it. We really wanted to leave it up to the proposers to understand what their application is, what their end use is, and let that drive the proposal and that drive the requirements that you submit. So that's very important to justify what's your target and why are you targeting that based on your application. We also included language in here that really describes, we anticipate a lot of data being generated in these projects, and we want to make that data as valuable as it can be to the membership to really raise all ships in terms of the knowledge, the state-of-the-art, state of the practice. So for all of these projects, we are really requesting essentially a data plan in terms of that we want to understand the type of data that's going to be generated, how you're going to be analyzing that data, how you're going to disseminate that data among the NextFlex community. All projects are required to do a quarterly technical report and quarterly webinar and produce, and Scott laid out all the deliverables in terms of data, but we really would like more engagement from these data generation projects to show and go out there and interact with the members and make that as valuable to the membership and provide data, raw data or process data. We really want to get that cross-cutting, that cross-pollination of the expertise. Also encouraging in terms of we're really focusing on manufacturing technologies or the components as a result of those technologies, looking to produce enough articles to have meaningful yield data, not just produce, you're looking to manufacture 1 or 2 of these. We really want to boost that scale number in terms of the articles that you're manufacturing, track the data, report on what your yield is like. That's really what the goal of this topic is. I included just the titles of the subtopic examples. So the bullets A, B, C, again, those are not, there's more details in the guidebook. Those are not requirements. Those are just areas of particular interest. So one is maturing high resolution multi-layer printing. A lot of what I described, it describes in terms of looking for heterogeneous integration of multi-layer die interconnects or chiplets. But again, it's very broad, really looking for you to have an application and end user in mind, what's driving those requirements. B is materials and process qualification and validation. Through those manufacturing processes, how do we take those materials, those components, how do we more quickly qualify them, validate them, generate that data, that yield, that performance? How do we then, there's language in there about supporting test method development standards. If use align with existing standards, if they exist, or the developing standards that some of the groups like IPC and SIMI are developing, align with the interests of those groups, engage directly with those, help the data that you generate, help engage with them directly and work with them. Say, if you see a gap in the standards, call that out. That's highly valuable, and support developing standards in those with those organizations. That's going to be key. And the third example is demonstrating reliability of hybrid electronic components in relevant operational environments. So a little bit less on the direct characterizing the manufacturing yield, but looking at that article that you manufacture, demonstrating that reliability. We talked a lot about reliability yesterday at Innovation Days for those that joined us, and in different aspects of, that could be extreme environments. The last couple of project calls, we had topics dedicated directly to extreme environments, whether it be for automotive, for defense needs, for space applications. But this is open. We're looking, whatever your application is, it might be office benign environments, but it needs high reliability and you need to demonstrate that. Fantastic. It's driven by what your application is. It's also pushing, use it and demonstrate it's reliable in a relevant environment, an operational environment, really looking at targeting TRL6, TRL7, showcase that it can be reliable, and that's going to be highly valuable. So happy to take any questions, and the pre-submission consultations later today will be around, but that's a very high level overview of 10.1. 10.2. So Scott mentioned another major theme that really came out of initially our modeling and design technical working group meeting that we had early last fall, identifying that the current roadmap, the state at which artificial intelligence and machine learning algorithms is really infused into industrial base and really everyone's lives at this point. It's moving so rapidly. Our current roadmap in modeling and design really didn't have much representation of artificial intelligence. So we've changed that. We've added some focus in that roadmap, but we're really looking to explore how can we implement AI and ML tools, not develop them. We have specific language in there that the focus should not be to develop those software tools, but implement them in a manufacturing setting to increase yield, increase performance, increase throughput, increase how we model, how we generate designs, layouts, tool paths, how we test. Really looking to optimize, leverage these tools that are coming online and increase efficiency, increase accuracy, increase yield. Just through discussions over the last several months, through working with subject matter experts and where that can make an impact, we laid out 3 examples. The first is rapid material selection and process development. We get a new commercial ink comes out, or you're working with a developer on a ink that's being developed that's nearly commercially available. You want to see how you can implement that in your standard process, whether it's aerosol jet, inkjet, screen printing, whatever you're looking at, a standard manufacturing process in hybrid electronics. You want to see how quickly you can bring it in, optimize it, see how it performs, see if it aligns with the specs that you're expecting after post-processing. How do we utilize AI? How do we utilize ML to bend the curve and make that rapid, speed up that cycle to make a rapid material selection and optimize your process so you can get it in your manufacturing operation more quickly? The second, similar, but that's sort of materials selection and optimization. I should also mention we have language. It's not for material discovery or material design. We're not developing new materials. We really want to optimize commercial or near commercial materials for these projects. B is manufacturing in situ process control for yield improvement. How can we implement machine learning into these processing lines using in situ processing? How do we involve closed loop control to increase yield, reduce rework, reduce scrap rate to really make these processes more efficient, make them more cost competitive by driving high yield. And the third is design and toolpath generation for complex 3D electronics. That could be conformal, doubly curved surfaces that we're looking to print on. We've relied on using 2D MCAD packages to design a circuit and sort of project it onto a complex geometry, trying to develop toolpaths that way. People have workarounds, but that's a known gap. And that's something that we've been working on. But we think AI and ML can really make a fast impact in terms of leveraging these existing software tools to give us better mapping into complex structures. It also involves complex 3D. You're doing multi-layer, you're looking at heterogeneous integration, structurally integrated electronics. How do we do electronic design and implementation of these designs using AI and ML? So that's 10.2. Again, $500,000, 18-month. I should have mentioned that on the front end. Next, 10.3, hybrid electronics platform demonstrator. So this is the first of our platform demonstrator topics. $1,000 of maximum institute funding available, an 18-month period of performance. And these are, as Scott described, what we're really looking for in a platform demonstrator, a functional demonstrator that is product-like. Again, not product development, but product-like in terms of a near finished in-use device that really showcases the capabilities, what's enabled by hybrid electronics for a specific application. We don't define specific area. We don't just say, where it's required for these application areas, but we do call out at least 3 bucketed areas that are really of high impact, really where we want to see what the latest is in the state of the art for these demonstrators. And they align really well with what ID TechX presented yesterday during Innovation Days in terms of the areas that are already seeing adoption of hybrid electronics components, and it's going to continue to accelerate. So we want to make sure that we have demonstrators that really showcase that state of the art. So those areas are wearable devices for human monitoring. So coming out of our human monitoring technical working group, really looking at wearables, whether it be for performance tracking, sports performance tracking, health monitoring, medical devices, an emphasis in terms of physiological, neurological monitoring, especially for high mobility environments. A lot of DoD interest in integrating health and performance sensors, human monitoring sensors into and onto the warfighter who are in austere, high mobility environments, making sure that you have high signal to noise, high performance to track whatever the metrics are you're looking to track on the individual. That also includes looking at long duration wear. So wrapping in interests of the flexible power group. How do we improve flex power solutions, integrate those into wearable devices so they can operate for longer, pushing 3 to 5 days a week of constant operation without having to recharge it? How do we enable that with advances that have been made over the last several years in that area, and continue to push that? The third is a little bit of a catch-all, but it aligns well with what I hinted at during the automotive panel yesterday at Innovation Days. So real interest in automotive, aerospace, and space applications. So those are all industries that are really demanding benefits from size, weight, and power reduction, really pushing that, but also are very risk averse and really need to show high performance and high reliability, especially in extreme environments. So it's really asking for a lot. And we really need, and hybrid electronics can deliver on that. We want demonstrators that show in those areas, here are the real benefits in terms of form factor, weight reduction, looking at things for automotive, like replacing traditional round wire harnesses with flex or in-molded electronics, interconnects for module interconnect, excuse me, that are highly reliable, looking to align that with standards, whether known industry standards, internal standards of a partner that look to, they're going to have to warranty these automotive OEMs have to warranty these vehicles for 3 years, 36,000 miles. They want to really fully vet and understand that these potential wire harness replacements that they're putting in these automobiles are going to be reliable. So doing your reliability testing, demonstrating what that looks like, and aligning that and showing that is going to be key. Integration of an automotive and aerospace area, integration of antennas, communications, sensors into conformal body panels, whether it be for an automobile or for a lightweight UAV or unmanned system, integrating these lower cost integrated sensors, lightweight benefits, but highly reliable. Space applications as well, really the most demanding environment, demonstrating that components for, say, CubeSats and constellation satellites, being able to implement hybrid electronic components that are high reliability performance at extreme environments. And the third, asset and structural health monitoring. So whether that be IoT devices, looking at tracking a small asset, or integrated into infrastructure, large structural, understanding the structural health of very large platforms, buildings. How do we integrate that? How do we demonstrate that performance, understand what metrics we're going to be tracking? What's the life of the device given the power requirements? We really want details in terms of who's the specific end user, who are the stakeholders, get their engagement. Scott described that on a previous slide in describing what these platform demonstrators, what we're really looking for. The more engaged, the more closer to a customer, an end user that describes, I really want this, here are my requirements, if you can deliver on this, that's powerful. So showing exactly what the use case is, when you can, and being specific as you can, is gonna be really bring a lot of strength to potential proposals there. You advance to 10 point, went too far. All right, 10.4. So topic 10.4 is additive manufacturing and repair of electronics in the defense industrial base. So this is the first of two topics, which is funded directly from funding from OSD Mantech for inclusion in PC10, which Scott mentioned builds on some previous efforts that were funded through OSD Mantech. Really looking at, in this round, focusing on where we can continue to drive down repair costs, life cycle costs, specifically for the defense industrial base. So this funding is coming from OSD. Where can we really make a near-term impact using hybrid electronics in manufacturing and specifically in repair to sustain more traditional electronics? We have PCBs, circuit cards that get damaged, fail. How can we more rapidly utilize additive tools to repair those, maybe at the point of need, at the point of failure, to get something back into the fight, improve readiness, make sure that the warfighter has what they need, don't have to go all the way, ship it all the way back home for repair, that can stay in the fight. Looking at rework, how do we work with the defense industrial base, the organic industrial base, to understand where those adoption of these manufacturing technologies can be. That's what the 10.4 is really focused on, those manufacturing technologies, those repair technologies. How can we really make an impact in the defense industrial base? How do we look at reducing dependency on centralized supply chains? How do we look at logistics? How do we make sure that those mission critical systems remain functional in these extreme environments? So engagement with DoD is going to be important here to understand what their needs are. We understand, this is where, come to us. We can do what we can to make connections if you need connections in those areas. But we're really looking to make an impact specifically in the industrial base. The examples here, I mentioned the repair, the rework, really to drive readiness, make sure that we can repair more traditional electronics like PCBs and circuit cards. We also included, I should say, with input from DoD and the membership through the technical working groups. This is something we've heard over the last several years from DoD, especially in the organic industrial base and working with defense industrial base partners, having to deal with obsolescence. You can't get a component, you can't get a device that you critically need for your platform or system. How can we, this is really showcasing, how can we utilize rapidly developing, rapidly manufacturing something that can then be put into a platform that you can no longer get critical components? How do we overcome some of those obsolescence as the defense industrial base is really supporting these platforms that are decades old, and a lot of the suppliers might not be around anymore. So that's another opportunity that we've heard. 10.5, this is the platform demonstrator for reduced lifecycle costs and improved DoD readiness. So that funding from OSD, this is really looking at demonstrating the capability similar to the previous platform demonstrator topic, how do we implement devices, systems with hybrid electronics that reduce weight, improve energy efficiency, enable capabilities not possible with traditional electronics? So we describe in the guidebook, you really want to describe what the market need is, who your stakeholder is, what the requirements are. But in this case, we're really looking for why hybrid electronics is a solution and how it's going to drive down lifecycle costs and improve readiness. So that's important. So it's sort of this 10.5 compared to 10.3. There's obviously a lot of crossover in terms of wanting to demonstrate capabilities. 10.5 is very focused on DoD needs, improving DoD readiness and their mission to operate, and making sure we're demonstrating the huge value proposition that hybrid electronics is introducing to them. We include some examples, again, not limited to these examples, but looking at low cost IoT shipping labels for location and condition monitoring for cold chain transport. How do we implement tracking for improved logistics? Low cost deployable sensor networks for threat detection. We've all heard in the news over the last year plus in terms of how Ukraine has pivoted to really adopt low cost, rapid innovation for technologies and sensor arrays. Looking to how can we do these attritable, systems for sensor arrays, really low cost, highly scalable sensor networks and sensor arrays. Factory maintenance and depot sensor arrays to improve manufacturing, logistics, and readiness. So modernizing the organic industrial base and the defense industrial base has been a big push. Where are the options for adoption of these technologies in their more manufacturing, kitting, logistics operation to improve readiness? How do we engage more closely with those depots and those logistics centers using our technology to get near-term impact? And finally, biodegradable sensor arrays. So similar to B, but really specifically looking at biodegradability for these more nascent networks for intelligence, surveillance, reconnaissance, ISR operations on the DoD aspect of it, but also a commercial analog of that, where with the interest of smart agricultural industry for soil monitoring, where you can dispense soil monitors into the soil. You don't have to go back and get out all your electronics. You have a biodegradable solution. So ideally, sort of a dual use area there. And finally, 10.6, this is our open topic for new project leads. $400,000 in maximum government funding, 12-month duration. This doesn't have a specific technical focus. We do require you to align it with the NextFlex gaps that are identified or areas of interest are identified on the NextFlex roadmaps, whether it be the member benefit version or the public summary version, or a need that is not on there, or we're not considering. Again, we want to be completely open to your solution. So bring us justification for why this is a critical need, what the impact will be broadly to the community. And that's important for this topic when it comes down to selection of proposals, because it's so open. It generally ends up being a lot of apples and oranges comparison, and working with the reviewers, working with the technical council, the governing council to understand which project would have the most value, engage really the broadest participation to really have an impact, really move the membership and move the community in terms of the knowledge gained. So it's an open topic. We request alignment to the technical working groups. In terms of eligibility, this topic is only eligible for organizations that have not led a project back to PC5. So if you're from an organization that has previously led an NextFlex project from PC5 to PC9, you're not eligible to lead in this topic. You can participate. There is language in there that describes no more than 60% of the funding can go to partners that have led projects before. We're really looking for a majority of the funding to go to those that have never led a project before. And there's several members that have led numerous projects that can advise on this. I'm not going to volunteer people, but it's a very important topic to really continue to increase the range of those that have led NextFlex projects. So if you have any questions about eligibility, let us know. That's an important one. We strongly encourage the pre-submission consultations for all proposers, but especially for the open topic ones, so we can help you provide feedback on what makes a strong NextFlex proposal, what makes a strong proposal to the open topic. We can introduce you to potential partners to build your team if you're not familiar with the industrial base and the system and the ecosystem. So highly encourage you, if you're considering that, to reach out, and we're here to help you. So finally, I want to finish and talk about that evaluation criteria. So you've got your team, you've submitted your proposal. Here's how we're going to evaluate it, and I want everyone to be aware of this so you can craft your proposal to be most responsive to the evaluation criteria that we lay out. Scott and myself have really both been pushing the pre-submission consultations, keep us busy over the next several weeks. We always say that when it comes to evaluation, we want the strongest proposals that we can to make our jobs harder. So we really are happy to provide input that makes these proposals stronger. So we provide exactly how they're going to be evaluated. So Scott mentioned at a high level the process, peer review process made of NextFlex members, government partners, NextFlex staff. There are rare cases where we've pulled in other subject matter experts in a particular area under the confidentiality of the participation agreement, but that's really a rare case. But generally, it's again, member-driven, member-selected projects. We evaluate the proposals. The scorecard I think on the next slide, it's included in the guidebook, shows you exactly what the evaluation criteria are, how the scoring will be done. We compile those scores, we analyze those scores, we look at the comments from the reviewers, which are incredibly helpful to take that to the technical council. In cases where the numerical scores are close, we get the reviewers together after the fact to discuss the strengths and weaknesses of the proposal. We really want as much information as we can on the potential value of funding the projects when it goes to the technical council, discuss it with them, and take that to our governing council as well. Excuse me. So everyone should know everything on here. So go ahead and read right now, each line. So this is the scorecard. This is included in the guidebook. It shows the 7 proposal sections that we recommend the structure of the proposal be. This is all laid out in the guidebook. It has the 14 evaluation criterion that will be used by the reviewers. It has a description of each criterion there, and it has how the scores will be compiled from 1 to 5. The top half of the scores are what we call the technical merit and transition potential scores, or the technical score. The others are the non-technical components. What's the market? What's the MRL assessment? Really, what's the cost? The cost share? Other considerations. I have a call out there in PC9. We added in addition a new criterion focused on tech transition potential. We've retained that. Again, that's only as important, if not more important, than it was in PC9 to really have a strong commercialization plan, tech transition plan. So wanted to specifically call that out. So in terms of, we compile all these scores, we also ask the reviewers what the strengths are, what the weaknesses are, should the project be funded? Is this a fundable project from their perspective? We take all of that data. We typically use the technical score as the leading indicator, and then have a discussion with the reviewers, the technical council, and make the ultimate project selection based on the strengths of the proposal and the portfolio proposals. So I just covered a lot of this. So we will rely heavily on the technical score and that relative ranking within the topic. Scott mentioned it, but it is peer reviewed. We do deconflict. So if your organization has submitted a proposal to one of the topics, no one from your organization can review for that topic if you're a potentially funded partner under that project. So as a lead or a sub development partner, no one from your organization can review or vote on it when it comes to technical council or governing council. So we really want the strongest. We want to eliminate any conflict of interest. If you're a reviewer, if you volunteer to be a reviewer and you see a potential conflict, please let us know. Happy to deconflict that. That's really our goal. So all of this information we present to our technical council. They'll develop a recommendation to our governing council, and they'll ultimately make the selection, as I mentioned. So my call to you, please volunteer to review these proposals for Project Call 10. So there's a QR code on there. It's vitally important, completely member-driven effort, as I said. So please volunteer to review these topics. You'll have the option when you go to that FormStack link via the QR code, select which topics you'd be interested in reviewing based on your subject matter expertise. If you're considering submitting a proposal into one of those topics, you don't know yet, but go ahead and click the box. We will manually deconflict you if you end up submitting a proposal. but I, like to get as much interest as I can in being reviewers, because we'd love to get the members engaged, and it's vitally important to have the member engagement for that the review process. Please recruit others from your organization that aren't here to be reviewers. It's important to have a diversity of reviewers. We also don't like to overburden our reviewers. We typically give, 3 to 5, maybe 6 proposals total to read. We try not to assign more than one topic to an individual. So, you're really trying to focus on one particular topic. So please go ahead and volunteer. And again, all reviewers should be familiar with either NextFlex projects, or, the subject of hybrid electronics in general. So please review or please volunteer. We'll share the information after this, so you can volunteer. You don't have to scan it right now. So that's all I have for now. Maybe I'll welcome Scott back up, and we're happy to take your questions that you might have, either in person or virtually. And I think there'll be a microphone going around. So if you have a question, please wait till the microphone gets to you, so those that are attending virtually can hear the question.
As far as like the wearable monitoring system, it's written towards, actually monitoring the health of the person. But I was wondering if it was monitoring external hazard conditions of the person. Is that something that would fit in this topic also?
Yes, absolutely. So that is on. There's aspects of that on the human monitoring roadmap in terms of needs in that area. For any of the topics, we specifically called out human monitoring because that's really the focus of it. But there are aspects of environmental for wearables, and again, we really want proposers to bring a known need, justify that need, and have that stakeholder that's defining those requirements. And if you have that for that application, that's fantastic. That'd be
Human monitoring, for example, first.
Yeah. So again,
Get contact type sensor the person hangs on the uniform or what the uniform monitoring.
yeah, absolutely. Yeah. So yes.
We have an online question.
Okay. Can I get them on here or?
Hi, can you hear me?
Oh, yes, we can hear you.
Hi, this is Anju Tur. I'm an assistant professor in Georgia Tech. I have a question regarding the qualification as a new project lead. So the way it is written, and you mentioned, it seems like this applies to the organization. So, like, how would it be for like in university? Because I'm not sure if, like, as a Georgia Tech, have they led any of these projects or not? So how can we, confirm if we could qualify as a lead or not?
That's a great question. So, and it certainly applies to large companies as well, where someone in one division might not know that another division has led projects previously. So the simple answer is, you ask the question, and we will let you know. In the case of Georgia Tech, yes, Georgia Tech has led projects since PC5, so would not be eligible for the open topic for new leads.
Okay, thank you.
I'm really happy to coach anybody from any other organization, specifically on whether their company or university has led projects.
Okay, thank you. I have one follow-up question. So is there a limit on the number of PIs that can be involved?
No, there's absolutely no limit. In fact, we really strongly encourage broad teaming to strengthen proposal teams. So if you have, I think a very common construction would be a large company, a university, and a couple of smaller companies or supplier type organizations supply chain type organizations that all work together to develop the proposal and then carry out the development work.
Okay, thank you.
You're welcome. Did I see a question in the room, or was that just a comment? Yes, your organization has led projects, if that was your question.
So I think so, Tom. I think you're referencing that while that question they might not be eligible to lead in 10.6, they can participate as a developer, just again, understanding that there's that funding requirement threshold, but if you've led a project before, you can still participate on the team for 10.6, you just can't lead.
Yes.
Wait for the mic, please, sorry.
Just a question about other agencies, the government agencies, for example, other than DoD agencies. Is it okay for any agency like NASA or DOE, for example? Is there a way, is there an NDA, is there a, they have to join or something, or, it's just, we just include them, is that?
So simple answer there. Yeah, any federal government agency is already, part of NextFlex. We work with folks from the Department of Energy, from NASA, from other agencies as well. So they can absolutely be included in a project team. They already have the required implied NDA, and all of that's taken care of. The only thing is we cannot send federal government money that we receive back to the federal government. So there has to be a mechanism for them to self-fund or fund through some other mechanism. But that is a fantastic way to strengthen a team, to have federal government partners. I think everyone's excited to move on. Oh, question in the back. I was going to say, I think everyone's excited to move into the proposers day portion of the event.
Thank you very much. My question was, with the cost sharing mechanism, to every proposal, so when should the cost share proof be provided through the proposal?
That's a great question. So cost share, let's start there, is required at least a 1-to-1 level. So for every dollar that's requested from the Institute, it has to be cost shared with a matching dollar. That is not applied on a per team member basis. So the proposal has to have 1-to-1 cost sharing, but the source of the cost share does not have to be distributed in the same way that the funding gets distributed. I think I mentioned, that cost share can even come from another outside party that's not one of the developers in the project. There's a document that we have posted on the PC10 website that talks about cost share, what is allowable cost share, what is not. The way that you demonstrate that is in the budget that is submitted. So there's a technical proposal and there's a cost proposal. In that cost proposal, you will show the complete cost of the project, including both what's paid for by the funding that the Institute provides and the cost share. And then you show the breakdown of the total cost. You don't have to line item every one of them, either in cost share or in funding. But it adds up to, your budget may add up to $900,000, of which $400,000 is funding request and $500,000 is the cost share that you're bringing. It is also worth noting that we made a modification to the proposal template this go around, or the proposal request. There's always been a budget summary section that goes into the technical proposal. We have historically gotten a lot of questions about what that needs to look like, and we've had people who essentially just reproduced their full unredacted budget table in their technical proposal, which is not what we're asking you to do. So instead, we gave you a template for what that budget summary table should look like in the technical proposal, and it's really just how much money going to which partner, and what's the cost share breakdown. So it's meant to be very simple. The full cost proposal, there's a spreadsheet for that, so you'll see the details there.
I think we have an online question.
So if you could, after I finish, repeat for the online audience, that would be wonderful. But it was about environmental monitoring, and if that goes into any of the categories that are included.
Sure. So I'll read it off and maybe you can answer, Nick. Although environmental monitoring, air, water, land, is so critical a topic, I'm not seeing a lot of focus on environmental monitoring demonstrator in PC10. Or would this fall under something that's already included?
Yeah, sure. I'll provide sort of my interpretation of that. So I say yes, and similar to the question that Steve asked in 10.3, it's broad. I mean, we define areas of interest that will make an impact. We just describe, wearables, automotive, aerospace, space, and asset and structural health monitoring. We don't have a technical working group that's specifically focused on environmental monitoring, but I would put it in that asset and structural health monitoring area of just trying to monitor an environment. So again, what I told Steve, you know, you're looking to justify the need there. You have a customer, you have requirements, whatever that is. If you're in trying to monitor the environment for a critical need, you know, that's going to be responsive. That's if you demonstrate the value and the capability, that's highly responsive, and that'd be of interest as well. And if that's a interest to monitor the environment, whether it be air, water, or land that's critical to a DoD asset and DoD readiness, that could be responsive to 10.5 as well. So thank you for the question.
Follow on to your comment before about the budget. So does that mean, I guess, when do I have to submit the entire budget? Is it at the time of the proposal, is it with the technical proposal?
Yep, so the proposal submission includes three parts. There's the technical proposal, the cost proposal, and what we call a one-slide summary version of a quad chart, essentially. So that is the complete proposal submission, all due through the same submission portal at the same time. So those are all due together. In the case of companies that have rate structures and confidentiality in terms of the submitting a full unredacted budget, we'll work with you on that so that you can submit a sanitized budget. It needs to be sufficient for us to do the review, but know that in order to go to contract, the unsanitized budget would need to be submitted directly to government so they can review and validate that it meets all of the requirements. But we do have mechanisms to handle that in the cases where you can't submit your unsanitized budget directly to us.
One of the people who had to do that, it works pretty well.
I'm glad to hear that it works well. All right. If there are no more questions, are we ready to move Jessica into the proposer state portion? All right. So how many folks do we have lined up, queued up already?
Big question.
Roughly.
15?
About 15. All right, perfect. So we have a period of time for these presentations, approximately a couple of minutes apiece. We have a break and we have then additional time for more presentations. If we get through all the presentations that we have loaded on the computer that you've submitted already, either in person or online, we'll go to the break period early. However, if you're in the room and you haven't yet given us a slide that you'd like to present, or if you're online and you are rapidly trying to put your slide together right now, get it submitted to us. We'll add you and we'll handle all of those that get added during this first set of presentations. We'll have those presentations after the break. So, Jessica, what do we need to do to queue up the first presentation? So. Oh, perfect.
So I think Scott actually just covered that, but basically the layout of, we're going to go topic by topic from the proposers that have submitted slides that align with one or more of the topics. Some people are interested in more than one topic. That's fine. We just needed some way to organize them. Again, a couple of minutes. I think we're going to have plenty of time, but try to be brief. Raise your hand. And if you're looking to have discussions, call attention to yourself, have group discussions after the fact, after we're done with all the presentations. But I think the idea is raise your hand and people reach out individually afterwards. So I think we'll go ahead and start. Let's see, the first one. So we got some that are basically interested in any topic. So I think we'll start with E-Ink and Mike McCreary if he wants to come up.
Leading us off.
Thank you. Yeah.
So let's see, advance,
That right.
advance reverse.
Yes.
I'm Michael McCreary. We're founding members of, E-Ink is founding members of NextFlex. I found out over the last several days that there are quite a few members that don't have any idea what we're doing. Oh, E-Ink, is that a conductive ink? What kind of an ink is it? Which is not us. But the reason why I wanted to start off is because I think what we're doing could be relevant to many of the proposals. We're not going to lead a proposal, but we'd love to help other people be successful in their proposals. Inc. is actually a display company, but it's relevant to to flexible and hybrid electronics. We were spun out of the Media Lab in late 1997. The allegory was that Professor Joe Jacobson had a book on the beach. He wanted to wave a magic wand and change it into another book, and then tried to figure out how to do that, which resulted in electrophoretic displays, today. Over the years, skipping over everything in between, we've grown to $1 billion a year company. So all of the Kindle, all the Kobo, all the electronic readers, that daylight readable display is us. All the shelf labels that you see, that's all us. We acquired Cypix, so we have R&D in Fremont here and in the Boston area. We have manufacturing, coating roll to roll, a mile at a time, electrophoretic top coats in the Boston area. And we have production in Taiwan and Asia, because nobody makes TFT backplanes in the United States, unfortunately. Initially, a very simple concept, oppositely charged black and white particles, bistable. So you take the battery out and 10 years later, you still have the same image. And if you want to get color, then you could put a color filter array on top. But what if you wanted a whole wall or big areas to get color? You'd have to have large transistor arrays, which is not practical. So you see here what's been developed in the meantime. We have full color. This whole room could be changing colors, full color, only using particles, reflective white and yellow, magenta, cyan, etc. But the other aspects that can be relevant to a lot of the proposals are it is Lambertian, viewable from broad angles. I said it was bistable, directly viewable without power in full sunlight. Simple segmented printed backplanes, printed by very many different methods, work. Flexible, absolutely flexible, both the TFTs as well. You could cut them out to any shape, doesn't have to be rectangular. There's near IR reflectivity. So if you had night vision goggles on in the black and white, you're in a dark room, you could read a Kindle just like it was daylight. Absorption, heat or cooling, these have been in space. You can imagine using them for heat control. They've been tested 1,000 feet, water. So that's not an issue. And switchable, minus 15 to plus 65. But you could throw these in dry ice and you'd still have you couldn't switch them, but when you warm them up, you'd still have the image throughout the that temperature cycle. So they're in lots of different products. I won't go through all these, but license plates, you pay your money and change your license plate. California, Arizona, a number of other states. Manufacturing, Kanban, smart logistics, being able to track information on the line. You could imagine sensors, all kinds of sensors. Vision is our most powerful, sight is our most powerful sense. We're talking about moving everything into a cell phone or whatever for information, but you could have things that turn colors or do things integrated with your flexible electronics as part of those proposals. These were some demonstrators over the last 15 years, all of which use discrete components, but the world has changed with FHE. This one, no battery at all. It's a thumb drive. The power of a computer changes the display and you know how much memory you've used. This was an early, made in the millions. This is an early Motophone and a PC board, but the back plane was printed onto the PC board. And so the display just involved laminating electrophoretic display material onto the PC board, and you end up with this nice candy bar phone. Well, we've moved on to smartphones, but you think about FHE and integrating a backplane with all the other printed electronics, and voila, you've got either color or black and white readout. Beautiful watch, these were a couple $1,000 titanium watches. Again, you can think of jewelry or other beautiful things where you have a visual effect resulting from your FHE. And this just shows some of the flexible components that went into that. These two are interesting. This I showed in the NASA in the kickoff. It's all discrete components, but the power requirements are so low that there's an antenna, a printed antenna in here for data from your phone, but also power. So there's enough power given off by a smartphone to power the display as well. There's no battery or anything on there. So this isn't, this is flexible, but the rest of it is not. So you could imagine a sticker that's completely flexible because the rest of this now is moved on and it's printed in hybrid electronics now. Here's some more recent things. This was announced several months ago. This is a cream guitar, color changing car. So any object can be color changing guitars. This is work that we've been doing with BMW. It has over 1,000 laser cut electrophoretic modules that are put on there, but this is all the conductors were ribbon cables and everything. There's no reason why it doesn't have to be a car, any object. There's no reason why you couldn't print all the electrodes, all the conductive electrodes onto what you're doing. And in the lab, we can spray coating. For now, we'd laminate it and then spray coat your conductor on top. So any three-dimensional object with printed electronics now could be color changing. This is for those of you that are familiar with San Diego, driving down Route 5. This is the San Diego parking garage, and there's over 2,000 modules that you see here that are completely, these are flexible photovoltaic cells that power this. There's no batteries. There's a super cap to store energy, completely solar powered. This has been in operation since 2017. So you drive by, you can still look at it. Again, the interesting thing is if you look at the electronics, this is all discrete components. So everything is flexible on this except for the electronics. So you could bend it one way, more or less. You couldn't wrap it the other way. So if the electronics were printed, it would be 100% flexible. And again, could be pasted up anywhere without having to wire it. So in summary, we would love to support other companies. If you have ideas for things that you would wear or monitors or stress sensors or whatever, why not have something that changes colors or gives you information that's integrated into your electronics? And we would love to work with any of you to help enable that. So more than my 2 minutes, but thank you.
All right, thank you, Mike. Let's see who's next.
Nick, did you want to give that ahead to the?
Oh, yeah. So, John, do you mind going? Because there's some people of interest that are in the audience that need to leave. I was informed.
John.
Oh, okay.
If it's all right with you.
Sorry. I didn't mean to be the one that kicks people out. Okay. So hi, I'm John Williams. I'm from Boeing. What you see here is concepts. They're from me. They don't necessarily represent the company yet. They're not approved by the company yet. The pictures here are Boeing's. They are copyrighted. Okay. So for 10.2 or 10.5, we'd like to utilize leaders from the NextFlex membership to develop a generalized manufacturing transition strategy. This isn't as focused as what you heard Scott and Nick talk about doing AI/ML on materials or a process. This is the broader, how do you get MRL 6 and 7 out the door? How do we use model-based systems engineering and some machine learning approaches that we can bring to bear simply to apply across the entire ecosystem to figure out how to get transition strategies that might work. To give it the really good description, I'll take Nick's statement yesterday. He likes his ice cream and he likes it to be put in different colors. And if he can have his color boxes for different ice creams, then he knows how to pick and choose which processes work. What I'd like to do is take that very same thing and do it across the community. So we would be looking for volunteers, Pradeep, Mark Pollux, Ganya, Nick Coop, Tom Revere, and I misspelled your name. I apologize for that. I already told him that this morning. And maybe 10 to 20 experienced NextFlex members and companies, academics that can come together and write a really great upper level PDR for how to get us out into the transition space. And if we can use that with companies and provide the software that we would, or the outputs that we would have every single quarter, the NextFlex members could come in, begin utilizing that and start their transitions as quickly as 3 months into the effort. Okay. So the project will choose, we can choose to support any other ongoing NextFlex proposal, any input, any content whatsoever. My requirement for any of the proposals that I do, and this has been pretty traditional for anything, we want a 50% cost match from you. So you put your skin in the game. Nobody is here to make money. We're all here to show that we can move the entire technology system forward. So that'll be a 10-2 or a 10-5, depending on how we want to strategize it. I really think it's more like a 10-5. It'll take a broader base, and I'd like to allow people, that more competitive edge. I think we need the same type of system down in a material set as well. Okay. We can go to the next one. You said you wanted me to do them all?
Yeah.
Okay. So this is a project called 10-3. It's a product transition demonstrator. We want to start at TRL, sorry, not even TRL. We want to start at MRL 6. So if you have a high 5, we're going to go straight into production. Okay. We have demonstrators that we are interested in. We want to bring a couple of other demonstrators online. We'd love to do the NextFlex A as part of the project. I'd love to grab a GE or a Lockheed or somebody else who's got something in E-Ink and that can run through a similar process and move that supply chain manufacturing to establish yield improvements. We will not be manufacturing it. You will not be manufacturing it if you're the designer. We're going to go straight out to the supply chain and have them start manufacturing the pieces and components. So the goal is not to have the designer have to touch the part. It's to have the TTMs and the take-cons and the nano-ops and the board assembly people all take the entire component system through process. They will send us back quality strips, but we do not touch it. Okay. In the end, they hand us a product, we go and we run and we test. That's the MRL 7. Yield improvement that they're going to run, and application-specific environment testing that you have to perform on your device, or we have to perform on our device, and reliability results. So for reliability, there are experts in academia here that know more than almost anybody else. They can come in and provide that expertise for the team and help you to craft and deliver the reliability results that you need. Okay, so the team demonstrates transitions. It really is taking this DoD manufacturing innovation system where you can take a prime, a material supplier, a board house, an application service. You end up on the business side. Nothing I make for NextFlex, minus a couple of small oddities that will transfer, is for Boeing to go off and produce on its own. We are going to buy this stuff. So we need a company and a transition partner and then it comes back to the prime and we buy it up. So that's the business. So if we can fill in the different parts of the business case and find all those groups and those suppliers, that's what we're after.
Hey, John,
Yeah,
so on this, starting at like, so you already have.
You-
products that
the-
are at that level.
we are at a 5+, ready to go to 6. And if you were at a 5+, ready to go to 6, I'll put your stuff on this project.
All right, so you have stuff, anybody else?
So we'll go in, I'll show you a little bit about the vision for it. Can I go down? Okay, so the call seeks partners to fulfill the task below. Designers have extensive prior product development. Exactly what you asked for, Steve. Manufacturing suppliers have significant say in manufacturing approach, i.e. they can come back and go, no, our tool sets really do this. Please fix it. Okay, materials and tool providers support the manufacturing suppliers. Okay, I really want to use new materials in some cases, but you've got to work through that supply chain. This is an integrated system approach. Environmental testing reliability are performed by academics and corporate teams using established processes, best practices, and known metrics. And then the business unit partners are expected to evaluate and establish their desired business outcomes. So if you're doing IoT, you can transition across different places. You see this development board we did for PC 6.3. We did this out of house. Okay, this was made by suppliers and partners. The yield wasn't there, so it really didn't make MRL6, and that was the issue. Here you can see a number of different small components. We believe there's a way to transition out of that and make these things simpler. Can we go to the next slide?
Hey, John, that reflection was pointed out that.
Yeah. I think the mic actually isn't, it's not really audible online, so.
Yeah,
Oh.
I can speak louder. So the next player made a point, hopefully the demonstrators that not do product development.
This isn't product development. This is proof that we can get to the manufacturing readiness level. That's what we're after. This isn't a product. This is a pre-competitive solution. Okay? If others want to join a pre-competitive solution, they can at the design phase.
You're trying to go from like 6 to 8.
I'm going 6 to 7. And if we get through or close to out of 7, that's great. We'll be in 7. And that's the goal. Provide this transition capability for the US government. Can we go to the next slide? So I put together a little path of how to get there. All this is best guess at the moment, okay? We're really early on to this. I've had a few days to read this. So layout, bomb, demo, team evals, that's your PDR. All that occurs in the first month because you should already have it. Okay. We'll do printed embedded passives, perhaps. That 2-layer print should be out, bulleted out. Okay. Either inkjet or screen print and laser trim, or if you got a full aerosol jet. I'm not sure how to handle some of the things that I don't know I can get out into industry yet, but I think those two can definitely handle it. We'll go to die attach using both solder and anisotropic conductive paste or some other material. The trick to this is very simple. You cannot be pre-pilot if you don't have a dual supply chain. So we're going to have to show how to demonstrate this 2 ways. Okay. Then we'll do an encapsulation, we'll do validation, you'll go to a mold package, you'll do field testing, do reliability tests, and we can come up with a schedule that looks something like this, where it's Q6 at the bottom, 18 months. So it's an attempt at moving very fast to prove that we can get products out. We will share every bit of the information that we learn. And any supplier and any designer can come in at any time. We're happy to work with you. We're happy to show you the entire process. I'd like to have team members that are also equally as transparent on this. I'm hoping to have 10 of you maybe working with me on this project, maybe 12 of you. Okay, we can handle the contracts and run them in over time so that we can get started really quickly with the people we absolutely have to have in the first month and then move you on to the effort. We'll be completely communicative while we're doing that. That's okay. But that's where we're thinking. Again, you bring your part and we'll bring our part and we will collaborate and we'll come out with something that we can hand to Congress and to the DoD as a capability. Okay, thanks. You got any other questions? No, I will say one thing. I'll have my team in one of these rooms. So if you're interested and you want to do this, please come see us and we'll talk and we'll start writing stuff down while we're here. Okay, thanks.
I have a related question. Next slide, but there was a talk by John Day at Ackman, Point B Consulting, talking with him, and he seemed to think there was a lot of potential that he could just bring right to market. I wasn't sure whether that's what hiring him to help with that type of transition, but it seems like he's had a lifetime of doing exactly that. So I'll consider him. Apologize for not knowing.
So for the folks online, I'll just summarize. One of the folks in the room asked the question that we had a keynote speaker the other day at Innovation Days who indicated that there are, he sees opportunities to bring some of these things to market, and asked whether we were considering somehow bringing, enhancing that kind of collaboration. And so I allowed that, so we're not going to ever stand in the way of those conversations proceeding. I would make the point that the project call activities, just to reiterate what was said a moment ago, we cannot and won't fund product development, but these things should be on the path toward being products. The demonstrator ones, in particular, are meant to show the potential for these things to become product. You need to make them competitive afterwards. This is pre-competitive. You're going to share the information. You don't want to share that secret sauce that makes your product the one that's going to be the winner in the marketplace. But helping you get to the point where the final steps that are required to get to that product, are tangible and understood, and what you're going to do with that. That is a goal that we have. We want these things to be transitionable, to have high transition potential, and so that if that kind of activity goes on in parallel, all the better.
Yes, you could run a parallel path, optimizing the product for market entry, so that it parallels to where the technology is prepared, ready for.
So
Although the current model doesn't fund that.
it's a parallel path to enable that market transition. Seems attractive to the folks in the room, just for those of you online. All right, Jessica, who do we have next? All right. I'm only seeing actually a fraction of the screen. So Georgia Tech, you can see that. Is it online or in the room? So for me, the top line is covered up by some information, so I can't read anything at the top of the page. Oh, contact information is at the bottom. Is this Suresh or Antonia? All right.
Do we have Georgia Tech on the line?
Why don't we skip ahead and come back? Yep.
Oh, sorry.
Okay. In topic 10.2. All right. Dr. Xiao Li. Object. Excellent.
Good morning, friends. I'm representing Object Tech. Thank you, Next Flex team, and giving us the opportunity to talk and present our solutions. So we are an AI software company located in San Jose here. Feel free to talk to us after the meeting. So we're a team material scientist, machine learning scientist, computer vision scientist. So we're providing AI solutions for smart engineering, hopefully to promote the ultimate engineering intelligence in the future. So more specifically, we're developing 3 platforms at this moment. The first one, we call this Deep Catch AI detection. So we can detect anomaly and detect the defects at down to nanoscale very fast. So we're about to launch this product this month. Feel free to talk to us and we can have a demo together. So the other development we're having is the NanoVision AI metrology. So this is to measure the objects, measure the nano features with the very large scale data sets, image data sets, and visual data sets. The other platform we are doing is the SmartFlow AI prediction. So this is to predict outcome and suggest the next action. So specifically for the SmartFlow platform, AI prediction, we're having a few modules implemented into the system. So first module we're having is experimental recommendation. So this is to learn the historic data of the R&D experimentation, and then we can provide recommendations through all the learnings. So the second one is a property or performance prediction. So this is for the yield enhancement through manufacturing. The third one is a predict maintenance to predict the downtime of the equipments through the reoperation. The fourth one we're implementing is the environmental monitoring to detect environmental anomalies through all the manufacturing line. So we're still active developing those platforms. Here we want to seek to join the potential partners proposal and support its product R&D through specific machine learning algorithm development, and hopefully our solution can provide some mature applications for the whole community in the future. Thank you very much. So we have 2 other teammates down over there, so we can also talk. If you're interested in our solutions, we can help to develop more specific applications for specific cases. Thank you very much. That's my introduction. Okay.
All right, thank you so much. Let's see, next, I'm moving on to 10.3. Sunray? Badoo? Oh, Isabella, are you online?
Yes, I'm online.
We can hear you.
Great, thanks. So hi everyone. So I'm Isabella and I'm representing Sunray Scientific. And so I'll talk today about Sunray's flagship product called ZTAC ACE. So that's anisotropic conductive epoxy. So this material is a replacement for traditional interconnects such as solder, wire bonding, and a variety of different applications. And so the image on the right shows how the technology works. So we're a blend of ferromagnetic particles in a polymer epoxy. Once exposed to a magnetic field, these ferromagnetic particles will form wires, so to speak, within the material, enabling conductivity. And so the value proposition for the technology is superior adhesion, which we've demonstrated through a variety of different SBIRs, STTRs, TACFI projects, the ability to do a low temperature cure, so 80 to 160 degrees C with no pressure. We are also working on optimizing a UV cure ZTAC as well. We also have the ability to connect to non-planar surfaces. Additionally, the material is fine pitch, enabling high density interconnects. Additionally, we eliminate process steps, enabling reduced costs. So we've shown in several different applications the ability to have swap C benefits, so reducing size, weight, power, cost within key applications relevant to both the DoD as well as consumer markets. So the technology is scalable via standard SMT processing, so compatible with an SMT line. It's also a green technology as there's no lead, no toxic solvents relative to solder. And in addition to these value propositions, we've also had several interesting developments within the past few years. We've demonstrated the capability for QFN and bare die attach on flexible substrates using ZTAC ACE, with the benefits being a low temperature cure, reduced high adhesion, enabling pads down bare die assembly on an SMT line. We've demonstrated using ZTAC in an automotive camera module demonstrator, replacing wire bonding in that application. Again, significant swap benefits, as well as low cost. And additionally, we've also demonstrated bare die attached to RFID on printed flexible substrates. So for this NextFlex proposal, we would really like to leverage the learnings from a lot of these different projects. So topics that we are particularly interested in partnering include 10.1C, demonstrating reliability in relevant operational environments. So we've done a number of different projects that show that ZTAC operates very well in cold temperatures, has excellent results for vibration testing, humidity testing. So we are definitely interested in that opportunity. Wearable devices for human monitoring. Again, this is an area that we have done some work to demonstrate the viability of ZTAC ACE, and we would be looking to leverage some of those learnings in an opportunity that is close to commercialization. Other topics include automotive, aerospace, and space applications, low-cost IoT as well.
All right, thank you, Isabella. Move on to our next presenter. Northeastern University. Ahmed, come on up.
Thank you. This was out of a project was funded at 6.8 for fully additive printed capacitors, passives, resistors, and you see, if you want to come and see them, I have samples here. So this additive manufacturing basically can be done in many different ways. We printed those down to 20 by 20 microns, up to 5,000 microns by 5,000 microns and higher. The dissipation factor was less than 0.01. The yield was 100%, and these were tested for reliability using ML standards 212, and we didn't get any failure for 600 hours with cyclic thermal. So this technology is available, but also it's very high rate. For example, we can do one layer with a metal or the electric in 1 minute. So this technology is available. We're not leading this. We're looking for partners to partner with people who want to lead, like John, for example. But also we're open to work with others. This technology is fully automated. You see the printer that we have, and this beside resistors, you can make inductors, and I have another call for the open call. So we have also done active components and active devices. So the capacitance tolerance, which is very important, is about 3 to 4%, which is very good for a printed capacitor. And like I said, the dissipation factor is less than 0.01, 100% yield. And that means, what that means is that you do not need to have components, pick and place components and solder them. You can print all the passives at the same time monolithically, already connected with the fan outs and all that stuff. And all you need to do is just add your dies using a flip chip, let's say, bonder. And so this is the capability that came out of NextFlex. And we're hoping now that we did the reliability, we did the yield and so forth, we're hoping that we can actually collaborate with more companies or organizations that can do full systems and that we can contribute these fully printed components. And the other thing is that for DoD related projects, this equipment and this fabrication is in an ITAR building. So basically, we can actually do ITAR projects as well. Thank you.
Nathan Lazarus, University of Delaware. So I'm going to be, I'm a former Army researcher that joined University of Delaware several years ago, and looking at a variety of different technologies for basically applying flexible hybrid electronics to DoD applications. And so I'm looking to potentially build a team, whether it's in 10.3, 10.2, maybe 10.5, looking at trying to really apply some of these technologies to DoD applications. We have a lot of expertise here in terms of things like managing power on the body. So looking at stretchable and flexible coils to transmit and move power around on the body, looking at using electromagnetics and other flexible hybrid systems to make flexible pumps, stretchable pumps to move fluids and for things like actuation of soft robotics. Looking at things like unconventional materials, like magnetorheological materials and other actuators, incorporating flexible and stretchable materials, as well as trying to apply stretchable materials to human monitoring and trying to harvest and sense different capabilities on the body. And so we're looking for partners to both essentially try to leverage some of these technologies to create a useful demonstrator for the flexible hybrid community.
Thank you, Nathan. Our next speaker is from HFR. Are they online? Are they in the room?
I'm online here.
We can hear you. Go ahead.
Hey, that's great. Thanks very much. My name is John Bell. I did some work previously with FlexTech prior to NextFlex. And so we're a small 10-person company based in Los Angeles. And we thought, hey, let's take some of the hybrid electronics and let's put them on the surface of the moon. That sounds like a pretty good demonstration to me. Luckily, by December 2022, one of the guys, our work, Dan, he used to work at Air Force Research Lab. He got a call from one of his friends who said, hey, we had a company just cancel out on a lunar launch, and we're looking for somebody to fill that spot. But we only have about 6 months, and we can't pay you anything, but would you be interested? So we sat down and had a chat and said, yeah, we'll build something for you and we'll pay for ourselves. And so the launch was initially going to be in 2003, but it actually got pushed all the way back to December of this year. And so ideally, we will have an experiment landing on the moon around Christmas time. And if you look at figure B here, you'll take a look at, this is all of our electronics, and this is the flexible circuits that we use to actually perform the experiments. And we thought, hey, you know, there's a lot of mass here compared to a lot less mass here. If we could somehow take this and make it hybrid flexible electronics, we could do some serious reduction of mass. And as anyone in the space business knows, mass equals launch costs. Right now, it's about $2 million per kilo to get something onto the lunar surface. So anytime you can drop the mass, you can significantly drop the price. So we thought we would do something pretty quick. I mean, we've said 6 to 9 months. I saw someone talking earlier about 12 months maybe being a minimum, but we can talk hopefully over the next few weeks with some of the folks at NextFlex as to how to maybe massage our pitch here. We've talked with American Semiconductor. They're out of Boise, Idaho. They've been doing the very thin film circuits for over a decade now. But I did hear earlier that there's an A21 microprocessor that was developed NextFlex, I think, with the Scandinavian company. So that's an Arduino-based device, which suits us fine. We actually are using it here. We're using an MSP430 from the Texas Instruments family. American Semiconductor have a thin film, 10 micron thick version of that. So we would basically say, hey, you know, we have developed these flexible lunar dust moving grids. We did a 2-year SBIR phase 2 with Kennedy Space Center a year or so back, learned a lot from them. As far as we know, we're still the only commercial company in the United States that will produce these dust cleaning grids. They are bendable dynamically. We've tested them to hundreds of thousands of cycles. We hope to be part of the Lunar Terrain Vehicle winner, who should be announced in the coming months, to basically remove dust from thermal radiators, from solar panels, from radio antenna, from optical camera lenses, all that kind of stuff, all the problems that the Apollo missions went through. So we would pitch basically a deliverable that we'd have a working prototype of a flex-based lunar regolith cleaning grid using ultra-thin hybrid electronics components to do the control systems. And we would test that in temperature vacuum chambers, ready for lunar launch. And if the funding isn't available for a lunar launch, we also have some experiments currently on the space station as part of a MISSI program that's a lot cheaper. We have them on the outside of the space station where there's a lot of atomic oxygen. It's a pretty nasty environment out there. Again, that would be an interesting step just to test flexible hybrid electronics in really extreme space environments, which I think is one of the big pointers on the DoD roadmap, not just electronics development, but electronics in space. So that's our pitch. Thanks for listening.
All right, thank you very much. Out of this world. I didn't see your contact information on the slide. So if you're interested in having people contact you, maybe you can drop it into the chat so others can contact you. So moving on, 10.4. Our first presenter is TapeCon. Is Brad on?
I am on. Thank you.
All right, go ahead, Brad.
Well, good morning. And I'm Brad Hall. I'm representing TapeCon this morning. I'm sorry I wasn't able to join in person this week, but we're not looking to lead a project this time, but we would like to, we're interested in partnering discussions with various partners. For those that maybe are not as familiar with TapeCon, we're a 5th generation family owned and operated business based in Buffalo, New York. We're a contract manufacturer, and we have about 4 decades of printed electronics expertise. I'll quickly highlight some of our capabilities for partnering. We print conductives, dielectrics, functional inks, adhesives, and coatings, as well as graphics. Most of our conductive printing is all done on screen assets, both sheet fed and roll to roll. We can do lamination and complex material stack ups. We have the ability to do precision die cutting, laser cutting, embossing, forming, and ultrasonic welding. We are SMT assemblers. We do that in both sheet and roll to roll form factors. And we have deep materials experience, and looking for a variety of different types of projects. You see a few of our photos there on the screen. I neglected to add my name and contact information, but it's Brad H @tapecon.com. And again, we would be interested in discussing with partners any applications, but we're most particularly interested in wearables, stick-to-skin solutions, and those that involve sensors or cloud-connected data collection. Thank you.
All right, thank you, Brad. Move on to 10.5. So our first speaker is Northeastern again, Ahmed.
Yeah, for 10.5, we would like to make available other technologies that we've been working on with NASA for gas sensors. And these are IoT sensor boards with different components, printed component. Not all components are printed, of course. The dies are not printed. And so in this technique, we go down to about 2 micron lines, for example, with 4 micron pitch. Also these are for variety of applications, including space applications. So some of the sensors that we worked on goes on the International Space Station. So this is a capability that we offer. It is, like I said, I'm listing some of the wiring here and some of the heaters also. We made a variety of materials, platinum, gold, silver, copper, down to a very, very small scale. And so this is so we're looking to partner with, we're not leading, we're looking to partner with, we provide this capability for any team that wants to lead. And like I said earlier, this is if it's an ITAR project, we are equipped to do that. I will talk about the other capabilities in terms of active components later. But this technology basically is, we've done a study where we found out how much the cost is, for example. So when you do a cost of a process, for example, like a fabrication process, you do for a FET or something, you have to use the embodied energy of a material. That means you calculate all the energy that goes in from the things that come from the mine, including actually the mining, for example, effort and energy, up to getting a product. And we compared, for example, our process compared to a fabrication process, and it was about was about 100 times lower cost. For example, you calculate all the energy for doing it additively and doing it in a typical fab. So some of that work is published. So if you like to see that, you can do this. The other thing that we do also is that we can actually have ink that's completely water. There's nothing, there's the particles in water. So our process actually is very flexible in that regard. So it is not, the particles are not biocompatible, but you can put biocompatible particles in there. But all our suspensions can actually work in water. The process works in water. You don't have to put surfactants. You don't have to put a lot of different chemicals. So the process is very bio-friendly, if you will. Thank you.
All right, thank you. So we're going to move on to topic 10.6 next, but I do want to make one comment. I'm going to just your comment about ITAR, your facility can handle that. I do want to make the point that NextFlex project call projects cannot address ITAR or any other type of export controlled topics. And that just stems from the fact that we have a requirement of sharing project call information across all members, some of whom, would have non-US persons, working in the US, but non-US persons having access to that information. So we have no way to control that dissemination. So the projects themselves have to be non-export controlled. They can relate to other areas that are outside the scope of the development work where that, where that content wouldn't have to be shared within the project. So just a comment because that phrase came up on the previous slide. All right, 10.6, Jessica, next slide. All right, Ahmed, I think you may be up again. Are you presenting for NanoOps?
So this one, NanoOps, which is was a member of Nexflex for about 5 years, has developed this technology, and this technology basically making devices active. So you see here, for example, this is these are transistors. Actually, I can show you samples here. We also made logic, and most of these things require high temperature. So for a while, this doesn't really work for a flexible substrate. This one also, this is silicon logic and silicon transistors. This is zinc oxide transistors. They all need higher temperatures in the process. So this temperature goes from 800 C to about 1000 C. So actually that, of course, doesn't work, obviously. But we just developed a new technology that we just published a few months ago. And this actually, you can do N-type semiconductor transistor at less than 200 degrees Celsius. And we've shown that. This was published. Be happy to share it with you. We can get on-off ratio 10 to the 7th, for example, and we get very high mobility. So now we actually have a process that would work that's compatible with flexible electronics. So if somebody wants to lead or somebody wants to work with us where we lead, we're open to both. We're open to suggestions and partnerships. But basically, I think this capability is now available, and it works. I mean, actually, most all the material, the electric, the metal, and the semiconductor can all be done at temperatures lower than 250. Thank you.
All right, thank you, Ahmed. Next, in 10.6, Conjure. Are they still here? Just left. Okay. Unfortunate. All right. Move forward. Advanced Printed Electronic Solutions. Rich, is Rich online?
Yeah, hi guys.
We can hear you. Go ahead.
Great. So the company is based in Fishkill, New York. We pretty much focus on additive manufactured electronics, application and systems engineering, along with process development, and offer contract manufacturing services in that space, using our internal platforms as well as the ones that we basically use our own systems, and we offer them as product platforms that are in development. One of the things that we've been focusing on is how do we deal with scalability and increase the throughput of these production scenarios, because all of our customers ask us one fundamental question, which is, it's great to do printed electronics or additive based technologies, but you can't build things fast enough to make it displace other technologies. So we've been on this mission for the last year or so to develop a scalable high throughput platform we call Matrix 6D, and that's something we're going to be showing at Rapid for anyone that's going to be there if they are around. And when in the process of working through that, we kind of also ran into a new problem, which is, well, great, the conventional tooling and systems that are out there, whether it be direct write dispensing or aerosol or any number of technologies, they really have limited capacity for material storage, often in the, to single digit or tens of millions of capacity. So that really limits the achievable production capability to just really a few units a day or manufacturing time to less than 1 day. So, that leads to certainly an increase in operational costs. So what we're looking to propose for this topic is basically a design architecture and solution for scalable material distribution, on some representative OEM tools. And, the goal is basically to enable, the operation of multiple instances of these tools on a continuous basis for an extended duration. So, the benchmarks would be, how many simultaneous processes that we can get going, and could we keep this thing running for a week without having to change the material, every hour or so, or less. So that's kind of the basic concept. And from a teaming perspective, we're looking for any DoD stakeholders or primes that would, be interested in, the outcomes of this, of this effort, and working with different tool OEM providers and material providers that could, provide the actual materials that we would, utilize. And from the other perspective is like, the production scenario specification definition, like, what type of factory pipelines are needed, how, what's the duty cycle in terms of like, how often, do they currently have to reload materials, and how long do they have to run for, and how many units have to be pumped out, that kind of thing, in terms of sort of metrics around that to help us firm up the actual requirements for what this, scalable subsystem would look like. And we're obviously interested in participating with any other team members on other project topic proposals, given, our capabilities. And that's it. Thank you.
All right, thank you, Rich. We were able to conjure up the team from Conjure, so go ahead.
I'm here all day.
Nice job. Okay. Hi, everyone. Hopefully most of you got a chance to meet me or my business partner, Tim. So I'm Sabrina. We're from Conjure. This is my startup company based on my PhD. I specialize in shape memory alloy, thin films, and thin sheets. Basically, shape memory alloys are smart materials that go through solid to solid phase transformation, fully metallic. It's nickel titanium based. And with this metal, we can really use it for actuators, substrates, interconnects. So think about new solutions for stretchable electronics that are all based on metal and that can shapeshift. So what's cool about this material is that we can really heat it, cause it to change shape to anything that we want to program. We have the ability to make this shape change temperature happen at anything between minus 100 degrees to about positive 300 degrees, easily at 200, but we're working on all the way up to the 300. We also can do laser manufacturing, so we can take thin sheets and put really nice structures into it that allow us to do conformal electronics. Maybe if I could zoom in. Nope, it doesn't work on Zoom, so no worries. So other things that we can do really would be, I would say, the conformal electronics. So imagine that we use our material as the next generation substrate. We want to basically fabricate it flat, put your 2D materials on top of the substrate, create all the circuits, components that you need, and then we can fabricate it after the fact to have a 3D shape that's fully conformal that we could use for wearables, use it for structural electronics. I would say it's really great for aerospace systems because it's extremely lightweight with one of the highest strength to weight ratios known to materials. So when it comes to projects, we're looking at hopefully doing an open topic for the new project leads. We would love to welcome your ideas of where the best applications for our material could be used for your guys' projects. But in general, we would also love to be a sub on any of your projects if you think our material could help you. So we can do this 220 nanometers all the way up to 300 microns. So if you have any questions, we'd love to talk to you. Thank you.
All right, thank you so much. Let's keep moving forward. 10-6. Artemis, is Eric online with Artemis?
Yep. Can you hear me?
Yep, we can hear you. Go ahead, Eric.
All right, great. Hey, everybody. My name is Eric Acom. I'm a co-founder and CEO here at Artemis Robotics. At Artemis, we're developing a new soft actuator technology that we call Hazel Artificial Muscles. On the left, you'll see the basic operating principles of the technology. What we do is take thin polymer films to form a flexible polymer pouch. We fill that polymer pouch with a liquid dielectric. Electrodes are printed on either side of that pouch. And when you apply an electric field across the electrodes, you get a change in shape of the structure. So you can use this approach to get a lot of different types of actuation. Primarily, we make actuators that contract and actuators that expand when they're activated. The result is these electrically controlled flexible actuators that have pretty high performance, especially for dynamics. They have high power to weight ratios, very fast response time. Because of their electrostatic operating principles, they're very efficient. They don't generate heat during operation. The materials, of course, are low cost and lightweight. So this can really enable systems with reduced complexity and unique operating capabilities. The middle here shows some of the applications that we're actively working on, working with DoD on some projects for bio-inspired robotics. So new underwater platforms with unique capabilities, also using the technology to create haptics and wearables. So integrating these flexible actuators into something, clothing or even into seating with some automotive customers to provide haptic feedback or to provide assistance. So the bottom shows an example of actuators used on a benchtop setup, showing the ability to suppress tremors. So for us, topics of interest, primarily we're interested in 10.6 for the open topic for new project leads, but also interested in working with folks on maybe 10.5 if there are specific DoD end users. The primary goal of a project would be to scale the manufacturing of the technology and some of the materials that we use. Right now, we're using a pretty manual sheet-to-sheet process to make the actuators here in Colorado, but we'd like to move to a more semi-automated sheet-to-sheet process and look for other opportunities to automate and improve both quality and the output of our manufacturing process. Also interested in better processes for more advanced dielectric materials. So we're seeking project partners that have expertise in manufacturing of flexible hybrid electronics, that have expertise in high performance dielectric materials and encapsulants, and then also potential end users for soft and wearable robotics. And then my contact info is down there on the right, eric@artemisrobotics.com. Thank you.
All right. Thank you, Eric. And I think we have one more. John, you're raising your hand.
Yeah. Are you interested in soft robots? Can we make a soft robot?
So someone in the room, Eric, if you're still on, asked if you're interested in soft robots and if you can make soft robots.
Yes, yeah, we were definitely interested in that. We just wrapped up a project with the Navy, creating a new type of soft robot using our actuators. So yeah, please reach out if that's something that somebody's interested in discussing further. We'd be happy to chat about that.
Fantastic. You got 2 thumbs up, so I'm sure he'll be reaching out.
Sweet.
All right, we have one more before we're going to go into a break. So our final for this session is University of Alabama in Huntsville. Nick, are you online?
Yep, I'm here.
All right, go ahead.
Hi, everyone. I'm Nick Ginga. I'm an assistant professor, mechanical engineering at the University of Alabama in Huntsville. And I'm interested in, a range of topics here, but, main one here I'm proposing is the 10.6. But my background really is in a lot of mechanical characterization and mechanical modeling, like finite element modeling of electronic packaging and stretchable and flexible electronics. So my lab has capabilities. We have traditional capabilities with a load frame with high strain amounts that we can do for testing with DIC, digital image correlation. But we also developed some other custom mechanisms for testing of stretchable electronics. Like you see this radial stretch tester that we have there that can do radial stretch testing of stretchable electronics, where we're not just doing uniaxial stretching, but we're doing, multi-directional testing. This can also do, one axis stretching, but we can, the idea is really to do multi-directional testing. We can do it in, single monotonic loading and also cyclic loading. So if there's any demonstrators that need to have any type of stretch testing or for reliability testing, then this is something that we can definitely use that for. So yeah, we have a lot of capabilities here for this kind of more big topic here that we have for this call of reliability testing. So whether that's more traditional flexible electronics or stretchable electronics as well. So yeah, I was kind of presenting that for a couple of those different calls, 10.1 or 10.3 or 10.5, any of those using stretchable electronics. Also, like I said, we have a lot of experience with finite element modeling, so trying to give some guidance on how do we design these better. We can play around with the different type of parameters, different material properties, different thicknesses, different geometric shapes to try to give some guidance and design rules for creating devices with better reliability. We also been dealing now doing some finite element modeling and also testing of liquid conductors. So I know there's a couple industry partners that have backgrounds with that. But we have been doing some mechanical modeling to better understand some of these liquid conductors under multi-directional stretching as well. So anybody dealing with liquid conductors or any of the stretchable or soft robotics, I think I'd be interested in speaking with anyone from those disciplines. So looking for industry partners dealing with materials and manufacturing, also anyone dealing with stretchable or soft robotics, and also multi-layer hybrid electronics as well for some of our final and modeling capability for designing for reliability. And my contact information is down below. It's just my name, nick.ginga@uh.edu. And you can also check out our lab website, which is the Mechanical Experimentation and Simulation of Small Scale Materials Lab, MESMAT lab here at UAH. And that's it. Thanks.
All right. Thank you, Nick. So we are going to move into a break. So 30-minute break. We'll reconvene at 11 a.m. Pacific here in the room, and you can hang out online. If you haven't and you'd like to do a slide, feel free to go over to the desk over here and you can provide a slide. If you just want to stand up without a slide, happy to facilitate that as well. So get your conversations going over some coffee and some snacks, and we'll see you back here in about 30 minutes. Thank you.
Hey guys, I'll offer this. Doing a new project, never got this going. Before. I've got a lot of experience. I just want to talk about having
Yeah.
Hello, everyone. We're in about 2 minutes, we'll get started. So if you could wrap up your conversations and sit back down, and thank you. All right. sorry for the additional delay. Hopefully everyone's having some great collaborative conversations, but we're going to go ahead and get started. If you can go ahead and sit down. Thank you. All right. So we got a couple more slides added into the deck from people in the room, and I think people online as well. So it's great to see such collaborative spirit. So let's keep going. Let's move. Let's see if this is going to work. All right. So now we have UMBC. They're online, I believe.
Yes,
All right, we can hear you. Go ahead.
thank you. Hi everyone. My name is Subham Lee from University of Maryland, Baltimore County, and we are working on design of a flexible or stretchable electronics using machine learning technique. So as you can see on the top left corner of this slide, we have tons of applications of flexible stretchable electronics for sensing, energy transfer, or energy harvesting capability. So, but in common, the flexible or stretchable electronics design is a very hard issue because we need to put some dense manner of the line layout into a two-dimensional limited space. So to account for that design issue nicely, we thought about using reinforced learning, which is kind of machine learning technique, so that we can take the image of line layout into the design input to our network. Then you use some simple simulation tool and gather some data to be stacked up on our database into the pre-type data structure on the top right hand corner of this second portion of my slide, so that the stacked data can be used to train our reinforced learning process and to train the convolutional neural network. So I used and applied this design technique for the design of the cross-line minimization, which is kind of a line layout design problem to minimize noise, which we call as a crosstalk. So we have design study on the bottom left-hand side to compare the machine learning technique being compared with the generative algorithm. So in between two methodologies, we were able to obtain very identical looking design when we designed the line layout from the top left corner to the top right hand corner to the the shape of the design space. So, but here the machine learning technique required much less time, like less than 1% compared to the generative algorithm. So let's say if generative algorithm used more than 4 hours, then machine learning technique was able to get the design in like a few seconds, for example. So now we are in the phase of expanding our design capability into stretchable electronics on Fabric to design a wireless power transfer line layout onto this attachable patchy, like a Band-Aid patchy, or even global surface, which is also stretchable as well. So I think here in this design problem, we have to account for a multidisciplinary design requirements from electrical performance like inductance and capacitance, as well as mechanical performance, which is durability and some avoidance of the line delamination in between conductive and substrate patches or something. So I think our design problem and project topic falls into topic 10.2, which is AI and ML for design, manufacturing, and qualification of the electronics. And I'll be happy to talk more if you are interested in this topic. And you can find my recent publication information on the bottom. Thank you so much.
Thank you so much, Subham. We're going to move on. Iris Light. Pretty clear.
Hi everyone, I'm Pradeep Subedi. I'm an environmental engineer at Iris Light Tech. Coming here, I wasn't planning to do this. John from from Boeing. He inspired me like, show your technology and see if we can find partners here. So that's what I'm doing. And thank you, John, for inspiring me to do this. Coming to this, especially like on the second day of the booth, the exhibition hall, what I found is like most of the inks that we use in flexible hybrid electronics right now is metal-based ink, and there are some semiconductor inks that are coming out. We are working on one of the semiconductor inks, and we have validated the repeatability of our ink. So you can see like we use aerosol jet printing for printing our ink. The ink right now, what we have is can be used at 2 micrometer wavelengths, like it works at 2 micrometer wavelength for detectors. That's what we validated and we're working on. And so we have a really good batch to batch repeatability of our ink, and also like same batch repeatability below within like 10% error. Recently, we have not completed on the wafer level deposition yet, but we have used same technique that is capable of doing wafer level deposition, and found that there is no degradation of ink, and it performs better than what we have achieved with AZP. So if this is something that you like to work together with, please find me. I'm here. And also like, I do not have information, but I will try to put my information out there. Thank you.
Great. Thank you, Pradeep. Next,
Can I mention something briefly?
we have Brewer Science. Adam?
Excuse me, can I mention something briefly? This is Subham for the first presentation.
Thanks. I wasn't planning to step up here, but I was inspired, I guess. For those of you, I'm Adam Scotch from Brewer Science. For those of you who had were fortunate enough to get the opportunity to hear Dr. Brewer's talk on Tuesday, I think you got a little glimpse of how Brewer Science operates sort of internally and how we approach problems and solve them. I think that's truly how we operate in our business. Brewer Science is a chemicals company, polymers company that has been around for over 40 years. All of our materials we are made in Missouri. We're based in Rolla and Springfield, Missouri. I wanted to share a little bit today that I'm part of our smart devices division. And while we were developing our water, gas, and strain sensors over the last couple of years, we've come up with a screen printable base material. I'll call it a base material. It's a polymer based material that we've turned into a dielectric layer, an encapsulant. We've made it into a strain sensor. It's curable. It's screen printable. It's curable between 180 and 280 C, and it's temperature stable up to at least 350 C. We are testing to see how much higher we can go. We think it could go up to 500 C with some tweaking. But we've printed it already on polyimide and on ceramic. We think this material could be used for a multi-layer pulp PCB. It could be used as an encapsulating protective layer. That's how we're using it right now on our water sensors to protect the circuits. We've also done a demo on a platinum RTD on ceramic as a thermally conductive encapsulation layer to protect the electronics, and it's temperature stable and thermally stable. So if I'm just throwing it out there that this is something that we have developed, we'd like to try and implement it into other devices or sensors. It's not commercially available. We don't sell this material. I think, but there's an opportunity for us to help integrate it into your applications. That's where we are now. So I don't have my contact information there. It's ascotch@brewerscience.com, or just find me. Thank you.
And very quickly, before we go to the next slide, Subham had something he wanted to mention.
Sorry about that. Thank you very much, Yashka. So I missed mentioning that I'm looking for a partner to manufacture the design and experimental validate in electrically and mechanically at the same time. And I left my email address on the chat. So thank you so much.
Thank you. Our next presenters from Oregon State. So Harish.
Morning, everyone. I'm Harish Subramanian. I'm from Oregon State University, and with me here is Devin. And we are actually representing our 10 PIs from OSU because we work on a lot of different things. So this kind of cartoon here kind of encompasses whatever we work on, right from hybrid integration to thermal management, making polymer biodegradable substrates, process optimization using machine learning, laser sintering, laser ablation, materials recovery, ink development, and also looking at environmental impacts or cost analysis. Next slide, please. Oh. All right, so this kind of, it's a busy slide, so I won't go through all of it, but these are kind of broad areas that we all work on, mainly biodegradable substrates, ink synthesis, materials recovery, interconnection and packaging, thermal management on flex substrates, device design development, and assessing cost cycle costs and environmental impacts. We have access to a wide range of print modalities, right from inkjet to dual head aerosol jet, plasma jet, and the micro dispense. And here are all the people who work on different aspects of things. Johnston is a low power electronics designer and stretchable electronics. Larry works on a lot of nanoparticle synthesis. Nirmala works on laser sintering and thermal conductivity measurements. Chi Hang works on ink synthesis. Joshua Guess is a thermals guy. Elaine is a bio person. Devin here, right here, works on process optimization as well as polymers. Tom Miller works on antennas. Carl is the cost cycle analysis, and I work on a lot of different aspects of print electronics. Here's a kind of a quick snapshot of the things that we kind of work on. So here is an example of using plasma jet printing to actually print pretty small features. We can print two metals at the same time. So this is a 500 nanometer feature that was printed through a photoresist onto a substrate. So in a single step, we are now able to directly print two different materials or even fill VS and use these as alignment marks for other subsequent processing. This is Devin, who works on novel polymer chemistry and developing polymer substrates as well as machine learning. Using laser sintering, Nirmala has demonstrated that we can get very good conductive films without melting the substrates. And the same process can also be used for removing and recovering materials. And then we can also print very good conductive lines on low temperature substrates. So if any paper-based devices are of interest, we would love to partner. Matt Johnston works on low power electronics. So he does a lot of low power electronic stuff and also integrating those with microfluidics on silicon wafers. And of course, Chi Hang works on microreactor based ink synthesis. So it's a one-step process where the inks are created in situ, and then you can feed them directly to the printhead. So that's all we had but we would all love to be part of a wide range of topics. So this was not specifically put in a specific topic as yet because we were representing a wider range of people. Thank you.
Oh yeah, and I'll say one thing. This is my first NextFlex time being around such a big group of NextFlex people. So first of all, my name is Devin Roach. Glad to be here with you guys. And I just wanted to say really quickly that I really enjoy working on bio-based materials, renewable materials, and things that can biodegrade. And so I'm actually really interested in the soil project called soil monitoring. So that's one thing. If you'd like to partner on that, I would love to partner. All right. Thank you.
All right, thank you, Oregon State team. Now Northrop, Anthony. Go ahead, the floor is yours.
Hi, everyone. I'm Anthony Chico from Northrop Grumman. I work over in the space part of the company, but that doesn't mean that we don't have additive manufacturing FAHE interests in other parts of the company as well. Let's provide a quick slide here just to show you a little snapshot about what we do. We use additive manufacturing in all parts of the product life cycle, everything from prototyping to flight products to sustainment on vehicles as well that we support for the government. Go to the next slide here. Maybe that does it. So just a quick highlight where we see at least FHE and print electronics going for us in the future. Especially one of the things that we look at here is a lot of times harnesses and spacecraft. And that's one of those things that we think that there's a potential for reduction in the amount of spacecraft harnesses, the weight that we have for it, and even the complexity that's associated with it as well. But the other part of it is also from a packaging standpoint. So if we're able to swap out components on a spacecraft or between different serial productions of spacecraft as well, where we have almost a constancy in how we are able to produce integrated layups for spacecraft and be able to do that. That's something that's also of high interest to us as well. A little bit else, kind of going further out where we see things coming. One of the things I don't list on this slide in where we see the biggest part of this is really just the responsiveness that additive processes can have when it comes to trying to produce spacecraft. And so one of the things that we look at is whether or not we will be able to also produce things on the ground, but also produce things in space as well, and have a responsive type of space architecture where, for example, if you had a fire that was occurring in California, which obviously we had a very bad fire season this year, could we actually just print the satellites in space and send them out to us so that we would be able to get information down to the first responders as soon as possible, instead of having what can often be a 24-hour delay for them getting data for where the fire has been and where it's going. So what do we see? There's a lot of outstanding issues when it comes to print electronics and being able to use them for spacecraft. But that is to say that I think a lot of these things are being worked. Right now, we're interested in really all the project areas. I'd like to thank NextFlex as well, for sponsoring this in association with the conference right before this. It helped us put together one of our teams for one of the project areas here. But we still have interest in all of these. We're particularly interested as acting as the transition partner in any one of those topic areas, and especially working with universities and finding university partners that want to enter this type of field. But then also other fields that Northrop Grumman works on, whether it be munitions, whether it be aerospace systems, or whether it's in ground control and ground systems as well that we support for our troops. So just provide my information right here, and thank you very much.
All right, thank you, Anthony. Next, Lockheed Martin, I think.
Yep, I'm here.
Yep, go ahead, David.
Good morning, everyone. My name is David Ortiz. I'm representing Lockheed Martin, specifically the Sikorsky aircraft line of business. Unfortunately, we didn't have slides prepared, so I'll provide a few brief talking points and try to keep it fairly high level since it might be hard to follow without the slides. But Lockheed's been a longtime member of NextFlex and has a lot of interest in several of these project calls, primarily more on the side of integration, testing, and application. We are particularly looking in this project call around interested in topics primarily 10.3 and 10.5, looking to either lead or team with another organization in NextFlex, specifically looking at ruggedized sensor or novel sensor integration and development and deployment. Some of the hard problems that we're still looking at trying to address are traditionally life-limited safety critical parts that's difficult to have in situ monitoring for. We're always looking for technologies that can reduce sensor weight, power consumption, that can are easy to or capable of integrating with the manufacturing process to enable smart components for these kind of critical life-limited parts to enable continuous life monitoring, in flight, on the ground, being able to traverse the boundaries of when control laws change, when the monitoring conditions change for components. Some of the biggest things that we're looking at are embedded sensors, smart components, integrated conductors and power sources. And like I said, we are looking to maybe shape an idea, to possibly lead one, or to team with someone who has an idea. And we have the capability to provide use case testing bed integration platform with some of our rotorcraft platforms. So if anyone is interested, please reach out to me or Chris Manila, our other contact for NextFlex, and we'd be happy to discuss potential teaming options.
Thank you, David. Next, Penn State University. You're online?
Yep.
All right, go ahead, Matt.
Hi, everyone. Yeah, I just wanted to give a quick update. Many of you may have seen our presentation on the Tier 3 membership call. We just tried to revamp that a little bit. Not going to go into all the details here, but myself and Professor Monagran are interested in engaging NextFlex for relatively new members, right? So our area is looking at how can we drive advancements for DoD applications. So we're interested in 10.1. We're doing a lot in the area of kind of looking at how we can move and close the gap on implementation of these devices. So we have a couple ideas on DoD applications where we think there's some gaps that we can close and do some testing in situ. Professor Guha is looking at how can we drive the AL and ML for design. So that's an area we have some ideas on, and we're happy to talk to anybody about. And then we're actively engaged with various Mantech projects. So looking at, are there some areas that we could help support either in testing, and or application space to help drive the electronics for defense industrial base. And so again, we have lots of areas across the lab, and happy to connect with different people, but we have, right now currently focused in my group on areas of DE or directed energy, high power, RF applications, advanced packaging, harsh environments and testing for harsh environments, point of service manufacturing, the design tools necessary to use those at point of service. We've done some projects with DARPA recently focused on high mix, low volume applications and how to leverage these tools to supplement some of the high investments costs that's required in the electronic industry. And then quite a bit of background in materials reliability and performance evaluation to support, projects. So have capabilities we can leverage here across campus. So some of them are listed here, but happy to partner with people looking at how we can engage the NextFlex community and support the advancement of this technology. So please reach out to myself or Guha if you have any questions or opportunities for engagement. Thank you.
Thank you, Matt.
Yep.
Next, Georgia Tech. Antonia, you're on.
Yes, hello everyone. So we are interested in studying flexible inks. As you know, they're important in building the circuitry, and specifically in our prior work, we found new mechanisms by which the microstructure, and here what I mean is the mix of something like flakes, so silver flakes, and the matrix. That's what I mean by microstructure, how it affects the overall performance, such as the fatigue life. That's kind of the middle picture that you see here, and particularly the electrical degradation of the inks. So we want to close the gap a little bit further, take it a step further, and we want to add the effect of geometry. And that's because, in most of the flexible electronic circuitry is done by using or taking advantage of these serpentine patterns in the inks, because they're thought to offer better performance than straight inks, because they can accommodate a lot more of the applied strain. That's what the first picture here shows from models. But our preliminary work shows that these effects that we identified for straight inks are just as important or even more important than serpentines, and are certainly not accounted for in these types of models that you see on the first figure. So in terms of teaming, what we would like to do is to find collaborators that would provide us with inks to test and collaborators for round-robin testing. We're mainly looking for 10.1 topics in this particular call. My contact information is on the bottom, and my collaborators as well for this project are also listed, Olivia and Suresh. If you have any questions, I'd love to, discuss this further. Thank you.
All right, thank you very much. I believe we have a couple of more. All right. Excellent, Tony.
Okay. Hi, everyone. My name is Tony Varghese. I'm from Boise State University. What we offer is a library of nanomaterialings and an extensive characterization on these nanomaterialings that can be suited for multiple printer modalities, including aerosol jet, inkjet, plasma jet, and extrusion-based printing capabilities. We have the capabilities to make nanomaterials and particle-free reactive inks also to suitable for certain materials. And we primarily work on developing these low temperature, low additives inks that can be stable and also reduce degassing when you go to like higher temperature and maintain a good electrical performance. And we also extensively study on the solvent and the ink properties to understand and develop a reliable inks that can be finely tuned for different modalities. And we have demonstrated using both aerosol jet printer, inkjet printers for multiple inks. We can print consistently close to 50 micrometer resolution using aerosol jet printer. We can use them for wafer scale printing and also achieve a very close to bulk-like conductivity. It's an example showing like a gold nanoparticle inks we developed in-house, and we can show that for other materials too. So we are here to collaborate, and if you guys are interested, we are happy to collaborate and work with you on ink and standardization or reliability testing, everything related to that. Thank you.
All right, thank you very much. Our next.
We're switching laptops.
We're switching laptops, all right.
On my file, just not go through.
Just a moment. And will we be able to share that online?
We'll make sure we get it. For the
Okay,
slide deck.
so for those of you online, we'll make sure to incorporate the next slide in the version of the slide deck that gets posted. All right, thanks. Thank you. Hi, everybody. Mark Chellingsworth with Heraeus Electronics. Thanks for the opportunity here to talk about Heraeus a little bit this morning. Last year we joined NextFlex. We're new members, but we just missed the tech day, so haven't had a chance to really see everything that's going on and to meet the group here. But happy to have the opportunity here this morning to go over a little bit. So, does this work here?
Just I need to share on the computer.
Okay.
Yes, thank you.
Okay, so Heraeus is a material supplier for assembly and packaging of electronic materials. And I wanted to highlight, we've got products that I think would be usable, materials would be usable for the projects that you're working on. So we've got a full line of thick film paste and inks, from high temperature inks that would be used on ceramic for high reliability applications, downhole high temperature type materials, to polymer thick film inks for printing on flexible circuits. So kind of the full range. All of these materials are developed and manufactured in Philadelphia. So, we're in the local area, and we've got an R&D group that's working on new applications, new materials, modifying them for the devices. But we also have other types of paste like sinter paste. So low temperature materials for very high reliability die attach applications, especially for power modules and power applications. Full range of solder materials, your standard lead-free materials. We still make leaded solders even. And also on the material side, I think, and adhesives. So we've got SMT adhesives, conductive adhesives that could be used all in these type of applications and projects that we're working on here. So we want to be involved in the projects. I saw some up there where, you know, material sets were needed, and think about us when you're putting together your proposals and you're looking for a materials partner on stuff. Okay. So my contact information's there, and I can help direct if you've got a project, if there's someone else within Heraeus who to work with, but I can be your main point of contact for stuff. And that's it. Yep.
All right, I think we have one last one we're queuing up. From Kevin from Electronics.
Yep, absolutely. No problem. Hey, everybody. So my name is Kevin Kamak. I'm with Electron Inc. I'm the Vice President of Government Strategy. And for those of you who aren't familiar with Electron Inks, we make printed conductive inks, or sorry, we make conductive inks that allow you to print metals directly from a solution-based ink as opposed to a particle-based ink. And forgive me, this slide I put together in about 5 minutes, condensed about 60 other slides. So it's probably not giving you all the information you need. But so we have a variety of metal inks that are already commercially ready. They're in commercial production at a qualified toll manufacturer. So even though we're a startup, these inks will continue to be available regardless of what happens in the future. And they're ready to be incorporated. Some of them are in commercial qualification in advanced packaging applications and space-based applications with a variety of different manufacturers. But there's a lot of use cases here for our materials. So we make several different noble transition metal inks. So copper, silver, gold, platinum, palladium, and nickel. Right now we have a ruthenium ink in development. We also make polyimide dielectric, and we have some carbon and graphene based inks as well. So the value here is we can actually our inks can be used directly with a digital manufacturing approach or inkjet printing, aerosol jet printing to print a device, a whole device. So for example, on the bottom left here, this is a device that's printed by IDS. It's a heater. It's an 80-watt heater. And apparently, according to the IDS guys, the client that actually wants to use this hasn't been able to break it yet. They're trying to find a larger power supply to see what they need to do to burn it out. The center image is one where we've been able to print 5-micron lines with our materials using an additive manufacturing approach. It's aerosol jet, I believe, with this one. And then on the far side, our materials have also been baked into large area manufacturing using roll-to-roll and kind of modern high volume printing capabilities. So we're looking for partners to collaborate with as a sub or on PC10, and really I think we can apply to all of the different project areas. So just please send me an email, and love to work with you.
All right. Well, thank you very much. So I believe that concludes the Proposers Day sharing of information and interests. Although I guess I will ask if there's anybody else in the room, because I've been very impressed and kind of inspired by the number of of folks who have come forward during the session today with additional information that they perhaps, saw something in another presentation and motivated them to share. So, all right, well, thank you all for coming. We're very much looking forward to receiving proposals on or before May 21st is the submission deadline, with your cover sheets due a week before that. The timing for the pre-submission consultations begins next week. So by all means, start contacting us to schedule those calls so that we can get into more details. Teaming does not end today, obviously. Today is really the first day of any kind of structured teaming activities. So if there are interests that you have, if there are others that you've met here today that you lose the contact information for, you see something, you're on your flight home or your drive home, and you think, I really need to get in touch with that person that presented the thing about, whatever, reach out to our team. We will put you in touch. We will be posting the recording of this session for you to review after the fact. Looking forward to great proposals. As Nick said, it is always our objective to make sure that you make our jobs as hard as they can possibly be when selecting the proposals to fund and turn into projects. So we're all looking forward to move this field ahead together and to get as far as we can. So thank you very much for coming. Look forward to talking with you more. Oh, sorry, we got a question. Yes.
Would the slides be available in a PDF file?
Yes, I'm getting a nod. So the files will be, the slides will be available as a PDF.
Okay.
And posted to the PC10 webpage. If any of you presented something today that you don't want to appear there, let us know ASAP, because we will get those up quickly. All right. Thank you again. Safe travels home, and look forward to talking with you more. There is space available if you want to continue some conversations for a while.